Good to go? Awesome. Hey, what's up, everybody? How's it going? Ooh, I got to close some stuff out here. Still have some stuff open from the last session. Yeah, Build Guild client. That is cool. Okay, so, hi, I'm Austin Griffith. I helped create the Build Guild DAO, and we are focused on developer education. In particular, we have this stack, Scaffold ETH, and this curriculum, speedrunethereum.com. If you are interested in learning how to build on Ethereum, or you even have friends that are interested in building on Ethereum, tell them to go speedrun Ethereum. I see some familiar faces that were at the last sessions. It's a lot of the same similar content today. We're just going to start with Scaffold ETH and build something simple, and then I'm going to hand it off to Kevin Jones, and he's going to do a like an extensions build, I think. So we're going to kind of try to wrap two sessions into one here. I'll do the intro to Scaffold ETH, and then he'll do that extensions. And I think maybe we'll even have like a little Q&A, possibly in the middle of them too, while he's getting ready. So Scaffold ETH is our stack of choice, and it's great for prototyping. Ooh, look at that, we still got our NFT up. I gotta close stuff out here, holy cow. Sorry, boop, 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 boop. Boop, 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 boop. Okay, here we go. So Scaffold ETH, you can find it at scaffoldeth.io. It's a prototyping tool, but you can also push to production. It's good for tinkering, and we'll get into it here. So there's two ways to do it. You can kind of clone the repo, and that's kind of the old way to do it, and the new way to do it is with npx create ETH. And npx create ETH is sort of like the step toward our extension system, so we'll be using that mostly today. And yeah, I think just to level set real quick, I probably didn't introduce this very well. We're gonna have like a whole day here. I think we're in this room like all day today, till like 6:30 tonight or 5:30 or something like that. So we're gonna do introductory content right now. I'm just gonna quickly show you how to build and ship an app. Then Kevin will do the extensions. Then I think we'll take a lunch break and we'll come back and we'll build a few more things. And then we're gonna have a CTF later today. So a capture the flag where you actually have to like hack some contracts and mint some flags. So it's gonna be a lot of fun. If you're more technical, the afternoon will be better. If you're just getting started, the morning will be better. I'm so sorry to all the people that I keep seeing at all these talks. You guys keep coming to my talks and I keep doing the same builds. Like I need to like innovate a little bit here. I try to do something a little different every time just to make it more interesting. But thank you guys for coming out and supporting. Okay, let's go. Let's get Scaffold ETH going here. So we're going to run npx create ETH, and it's going to be kind of like a little choose your own adventure here. It's going to take us through, let's see, this is Devcon app. I'm going to call it Devcon App 3, I think is where we're at right now. And this is kind of like one of our more controversial things. We kind of still have defaulted to hard hat. It's taking us a while to like really get Foundry the way we want in Scaffold ETH, but you can choose between hard hat and Foundry's almost going to be the default soon, but it's up to you. You can choose either one. Both are good. Foundry, you're going to spend more time writing your tests in Solidity, and so if you're building just like a super complicated protocol, like Foundry's probably the option that you should take because you're going to need to write lots of tests, and those tests run in Solidity. If you choose hard hat, it's a great option still. I think the deployments are a little smoother, and everything's in TypeScript. So I think hard hat leans a little bit more toward like the app builders. And they're doing a good job at like speeding up too. I think maybe one of the concerns was that Foundry was just a lot faster than hard hat, and I think they're improving a lot of those things. I just pick one randomly. I think I did hard hat for my Devcon app number 1, and I think I did Foundry for my Devcon app number 2, and I'm just randomly back to hard hat for Devcon app 3. But it doesn't matter whether you choose Foundry or hard hat, it's still going to be the same commands. We're going to do a yarn chain to bring up a chain. Yeah, what's up? That's hard hat. Hard hat is all your tests will run in TypeScript. So like when you build out a test bank in TypeScript, you know, go query this amount, make sure it's that amount, write to the contract and make sure it wrote correctly. You're going to be writing that in TypeScript. And so that makes it really nice if you're going to also be building an app, because you can get in and kind of copy that code right into your app. So if you're an app builder, sometimes writing those tests in TypeScript makes sense. But it seems like the GigaBrains are moving toward Solidity as a testing. You know what I'm saying? Like, I can tell that they're smarter than me and they know what they're doing, but I don't know exactly why, but they're onto something. So I think that like the Foundry and testing with Solidity is like the future and probably where we'll go. But as an app builder, I feel like I can relate with TypeScript and JavaScript more. And like I said, like when you can copy paste right into your app, it's really nice. Okay, so once everything is installed, and shout out to the organizers. This is cool. Like I've been to conferences before where I've done demos and the internet was not good enough to install this whole stack, and we just installed the whole stack just now. So shout out to Skylar and the team and the Devcon team, Nathan. Okay, and of course, all of you guys that are doing all the work behind the scenes. Okay, here we go. We're going to spin up our local blockchain. So like I said, whether you're using Hardhat or Foundry, it's the same command. With Scaffold ETH, we kind of abstract it away a little bit and just give you the commands that you need. That command was yarn chain. So I ran a yarn chain, and that basically spins up my local blockchain. And then I can do a yarn deploy, and that's going to deploy kind of like the template smart contract that comes with Scaffold ETH. And then we're going to do a yarn start in another terminal here. So it's kind of like launching a rocket. You got a few things here. It feels overly complicated, but once you figure out that this is kind of like mixing two packages together, and you sort of have this back end that is the blockchain, and then you have the front end, which is like your Next.js, it starts to make sense how this works. And Scaffold ETH particularly does a good job with taking your artifacts from your smart contract and injecting them into your front end. And I'll show that when we start writing the front end. It's really nice because it starts to give you hints and it knows everything about your contract already. Okay, so let's get into the code. I'm going to use cursor or code. Whatever, if you guys use code, you just do code dot, right? But I like cursor. Even if I'm not using the AI feature, I just use it as my IDE most of the time. But it's really nice because it has this tab over here where you can pull it out and be like, yo, build some buttons, and GPT or Claude will just like inline write the code for you. So definitely, if you haven't checked out Cursor, go grab it. It's a great code IDE. Okay, so if we look at our packages, we have Hardhat, and then we have Next.js. Like I said, that's kind of like your back end and your front end. And if we get into Hardhat, we can find the contracts. Scaffold ETH starts with this kind of generic contract that has a little bit of everything just to get you started. A lot of times you might just like carve it out, right? That's why we called it Scaffold ETH. You kind of need the scaffolding, but then as you get the thing built that you want, you can kind of tear down some of the scaffolding. Ooh, I think my little mic is going weird. Okay, here we go. So let's get into this contract and look at it, and let's just tinker around. I think one of the first things to show off with Scaffold ETH is just this kind of dev loop you'll get into. And let's look at that. Okay, so we've got some, let's look at this smart contract. Is that big enough? You guys can see that okay? Yeah, okay. So you've kind of got your primitive data types, whether you're tracking addresses or strings or bools or numbers. There's mappings between these primitive data types, like for any given address, you can keep track of a number, like a balance or something. Events, the constructor, even a modifier here, which is a little goofy. You can kind of get the syntax. I would recommend Solidity by example. If you are feeling like you need a little bit more help figuring out the syntax and just getting a little bit better at just writing your first few smart contracts, definitely check out Solidity by example and just like go through each of these examples and just copy paste them into Scaffold ETH, and they're really great examples to learn from. Like for instance, like if we were going to go learn what a mapping is all about, we could get over here and we could copy this mapping and we could paste it into our smart contract and then go dink around with it, right? That's kind of like a good loop to get into. Let me specifically get to this contract and dink around with it, but I just wanted to show off Solidity by example as kind of a tangent here. Whenever you're writing your smart contract, if you're writing it yourself and not just prompting AI, you probably want to like go to Solidity by example and find some of these kind of nice copy-paste examples. But I'm going to close that out. We're going to go from memory here. Okay, so I want to look at this set greeting function. It looks like we pass in some greeting, a classic, greeting contract. This guy's kind of waving around. Am I okay here? There we go. Classic greeter contract. We're going to set some string, but this is the neat little code block that I want to test. Basically, it's if you send money in when you set the greeting, it sets this little premium flag to true, and I think that's going to be what we'll do here in a second. Okay, so once we have our back end up and we have our front end up, let's go visit our app. Here it is. So Scaffold ETH kind of comes with, you're going to write some Solidity, and then you're going to have this debug tab. Here, let me make this a little wider. There we go. See that debug tab? There we go. This debug tab, and this is going to give you this really nice interface where you can kind of just point and click, try things out. You can poke at your contract. You can test your assumptions. So let's go look at that greeting contract. Let's go set the greeting, right? And that's going to teach us about burner wallets and ETH to Way, a couple of the initial concepts. Let's just try to set it. It's going to yell at us. So if I say hello world and I hit send, it's going to say something like you don't have any money. And so right up here, there's a nice little, when you're on localhost, it recognizes you're on localhost and it gives you a nice little faucet button. But as soon as you push this thing to a live network, that faucet will disappear. So I'm just going to click that, and that should give me some ETH, right? Now we've got some money to work with. Now the second thing I want to bring up is burner wallets. You'll notice there's a wallet here, and I could connect my MetaMask if I wanted, but when we're doing local development, when we're doing quick dev, I want to be able to just like hit a button and send this transaction. I want to just be able to click it and have it go, right? Did you see that? Like that was a transaction. There's a transaction. That's a transaction. That's a transaction. You get a transaction. You get a transaction. So it's just faster, and it's a lot easier to kind of test what you're doing, to not have MetaMask popping up and switching the chain ID and a bunch of other things that you'll run into. But this thing's all ready to go, so by the time we push this thing to a public network, we'll be able to bring MetaMask in and we'll be able to hide those burner wallets, but for now it works really good for dev. And let me just triple down on the burner wallet thing real quick. If I open up an incognito window and I go to localhost, see I get this account, this sort of 1A55. Let me do that again. Localhost, and it's a new account, right? Because it's in incognito and it's keeping the private key at local storage, you're getting a new one each time you bring up that incognito window, which is super nice for testing. And I'll show you that in a little bit. But basically, you could say you have this function that you only want the owner to be able to call. With these burner wallets, you can kind of bring up the good guy burner wallet, bring up the bad guy burner wallet, make sure the good guy can do the thing, make sure the bad guy can't do the thing. It's not like an exhaustive test, but it's a great way to quickly test your assumptions. Okay, here we go. Let's go. Hello world 3. That's what I'm, oh, whoops. Hello world 3, send it. Okay, so I want to get this premium flag. See over here, these are all the it's reading from our contract, all these different values. And there's this premium flag here that's still false. So what I want to do is send in some money, right? The contract is still empty. It doesn't have any money. What we're going to do is we're going to send in 0.001. And here's the next weird thing about building on blockchain is this whole idea of ETH versus Way. And again, Solidity by example has a really good Ether versus Way explainer here. And when you put a 1, so when I'm in a smart contract and I put, a 1 right here, that is 1 way, right? And so if I wanted to send 1 ETH, I need to send 1 times, oh, get out of here, 1 times 10 to the power of 18, right? That is 1 ETH. And the reason is the EVM is a super simple little computer. It doesn't want to mess around with floating point math. So you don't do decimals in Solidity. You have to basically do whole numbers. So sometimes when you need to do something like take a thing and add 5% to it, you can't just multiply 1.05. You have to do some numerator denominator stuff. But the thing is right here, we have this little button, and it does that for you. Now, only would a developer need this. Once you start building your front end, you need to do the ETH to Way conversions all in the background, and the user should not know about it. You should just be like, I want to spend 0.01 ETH, go, and it goes, right? Or even better, the USD value of that 0.01 ETH, and then maybe the 0.01 ETH underneath it or something like that. But if I try to send this right now with a 0.01, it's going to give me like a big int error. It just doesn't like that, right? Developers need to remember, and this is why we put it into scaffold ETH, you have to hit this button and you have to take it times 10 to the 18, and then you hit send. And there we go. We made a transaction, and what I wanted to show off was if we send in money, it should set this premium flag to true. And it did. It's true now, right? And if we zero that out and send it again, does it zero? I don't even know. But we can test our assumptions. We can just try it and see what it does. Yep, so now premium goes back to false. Okay, so let's write a quick little smart contract app. And specifically, I want to show you the sort of like core game loop that you'll get into with scaffold ETH. And that's basically, let's get out of here. You'll add something, right? Like, what do we want to build? Do we want to build, I like the idea of the beneficiary. That one, I've got this like prediction, like simple prediction market that I want to build, but I haven't like fully thought it out, and I don't think I should just figure it out on stage. So I think what I want to do is do like a beneficiary and set it up so the beneficiary receives some money, and we have like a little front end where we can update the beneficiary. Just set something in a smart contract, and that whoever that beneficiary is will make the money. Okay, so we're going to have a public address oh, look at that, thank you. Beneficiary, okay, and it's set to the 0 address right now. If I were to deploy this, it's going to be the 0 app that is the beneficiary, but we do have a beneficiary now, but it's the 0 address, right? So let's start that off with, I think I'm going to do, let's go to address vision, atg.eth. I want to make this guy the beneficiary. Yeah, that dude right there, okay? And then I'm going to paste that into the contract right here. There we go. Okay, so now we have this beneficiary, and we're going to need probably some function that lets us set the beneficiary. And let's make that, we have this owner. I don't know. We're just going to make this public. So this is another thing I do sometimes when I do these demos is I make a very insecure app and deploy it to production, and I think I'm probably going to do that here. Basically, I'm going to let anyone set the beneficiary, and then I could delete all this stuff probably, but I'm mostly going to leave it. But there's this withdraw function here, and in this withdraw function, only the owner can withdraw the funds, and I don't want to do only owner, actually. I want to kind of get rid of this idea of the owner, and I want to require beneficiary. There we go. Man, Copilot is on point. All right, so, and then I want the beneficiary to get the money. Okay? And let's go test it out, right? Like I just made some changes to the code, and like this is a smart contract that's going to be moving money around, and I want to be a little bit more confident that I did the right thing there. So that's what this like core loop is about, is like testing those assumptions. I've said that so many times. I need to come up with a new phrase. But let's go set the beneficiary to, now watch this. Scaffold ETH has these components out of the box, like this address input field, which are really nice because they do ENS resolution, ENS avatars, you got the blocky, you have the address. But let's see what happens there. Okay, I was able to set Vitalik as the beneficiary, and I think I can set anyone, right? I can do atg.eth and hit send. Basically, anyone can set anyone as the beneficiary, and then whoever is the beneficiary, let's set this dude to the beneficiary for some reason. Send. Now, someone should be able to hit withdraw and pull the money out, right? So let's say a bunch of people came in here and said, hello world, and they paid 0.01, and they hit the button and they send it, right? And now the smart contract actually has money in it, right? There's $32 sitting in that smart contract now, and we just want the beneficiary to be able to get in here and hit withdraw, and we want to make sure that money disappears and shows up over here. I didn't watch very closely, but I'm going to assume, no, let's not assume. Let's figure it out. Let's prove it real quick. Let's set another greeting, send some more money in. So we're at 988, I'm gonna reload that. All right, 9882. Now if I withdraw, I'm watching here, what, like that decimal right there, right? We gotta make sure that, yeah, 99, okay, good. So this is not an exhaustive test, right? You want to build a whole test bank to make sure this thing does what it needs to do, and there aren't any weird edge cases where you're going to lose money or get money locked up. But in terms of our little smart contract, I now am able to like keep track of some beneficiary, and anyone in the world could set that beneficiary. And when they come in, only the beneficiary is able to withdraw the money, and it goes to them. It's a simple little app. You guys are the Solidity developers. You'll spend more time building things. I'm going to build a silly little example, but you're deploying an always-on app that will last forever, possibly longer than you, and it's nation-state level hardness. So don't get thrown off by my silly little examples. Like there's world-changing tech here, and sorry for my simple examples, but we're just going to build like this little beneficiary system. Okay, so it's sort of working. It does what we need it to do. I can set the beneficiary. There's some other functions here that I'm just going to leave. The beneficiary can do the withdraw. What I want to do now is go start working on the front end. So just to recap, the beginning of this is about tinkering with your smart contract and putting in some Solidity here, and then testing it out over here in Scaffold ETH, in this front end in the debug contracts tab. And you'll do that for a lot longer than I did. I'm kind of like time boxed here to a short window, but you'll get in this mode of tinkering with Solidity and getting things right here, and that will take longer, of course. But once you've got it, and let's just pretend I do. Let's pretend that I have built my whole app, I've tested it, it works great, it's very secure, I'm about to put it on a blockchain forever, and it's awesome. I'm going to actually take this import out too. I hate deploying that on chain and paying for it. Let me take that out here. There's some nice console log debugging you can do with Hardhat, and that'll spit out over here. Whenever there's a console log in your code, you'll see it over here in your blockchain, and really nice for debugging, especially when you're like, why isn't this decimal working? I thought I could do that, yeah. Okay, I just wanted to take that out and redeploy. Let's see if everything's happy here. Okay, we're happy. So you'll spend more time on your smart contract. I just did a quick smart contract. Let's pretend that it's all good to go. Now we're thinking about our front end. What do we want? We have this beneficiary, and we can set the beneficiary, and we can withdraw. I think I want some kind of front end that lets me put in an address and set the beneficiary, and then another address, and then another button underneath that that lets me like withdraw the money or something like that. So we're going to read and write from the chain in our front end, and let's go start working on that. So this is kind of phase 2. Your contract is pretty solid. You may come back to your contract and add some events in, maybe add some read functions, but generally the functionality is working and you're good to go. So most of the time now we're going to be over here in React land. And normally I would definitely just prompt GPT. I would not be writing this code, but I feel like that's kind of like lazy. Like I don't think it's, it feels weird to be prompting GPT in front of 30, 40, 50 people and be like, bro, please, full files only. Like, I feel like that is a weird experience to do in front of a bunch of people, so it still makes sense for me to maybe just like live code this thing rather than ask GPT. But if I was at home and it was just me, I would be yelling at the GPT to get it to work and not actually writing my components myself, but we're going to write them ourselves. And we're not actually going to write them ourselves. I'm going to go to the docs, and I'm going to copy paste. So Scaffold ETH, we go to the docs. There's this tab over here called Interacting with Your Contracts. And there's external contracts too, but interacting with your contracts is kind of the first thing. And here it is. Here's how you read from your contract, and here's how you write to your contract. And this is using WAGMI, so you could always use WAGMI from VM and look at their docs and go learn some things. We've wrapped it slightly because Scaffold ETH handles some wallet stuff and other things, so it's using the use read contract from WAGMI, but we called our own function use scaffold read. It takes a couple less arguments, and we fill those things in for you. It's a simple piece of abstraction, but we think it's the right move. Okay, so what we want to do is read from our contract. We have this smart contract that's keeping track of this beneficiary, and I want to display the beneficiary on my page, okay? And so far, all we have is the connected address. Oh, shoot, I got to go show the page. So we've been on debug contracts the whole time, but if I hit home here, this is going to take me back to the page, and I've cleaned out all the stuff that was here, so now it's just down to this. And let's see, what's welcome to, this is going to be called, I don't know, Devcon app 3, con app 3, the Benny. Beneficiary. Oh man, I didn't spell it right. Come on, help me. A-R-Y, did I get it? Oh, there we go. Thank you. Okay, and now that should change over here. There we go, okay. And it's showing us our connected address, has that little blocking and everything. But now what we want to do is read who the beneficiary is from the smart contract. And I've got that piece of code copied already, so I'm going to bring it in right here and paste. Okay, so this is where I was talking about. It's really nice because Scaffold ETH knows about your contracts. So as soon as I hit one of these buttons here, let's see, I think I just opened the quotes maybe. It's going to start, it's not. Which button is it? It should autocomplete to whatever the value is in the contract. Something is not right. Let's see. Oh, we need to import it. Here we go. Let's try that. Is that what's happening? Basically, when I open this quote, it should give me, there we go, that's what I want. So this little list is the stuff from my smart contract. So as I'm banging away on that Solidity and I write out my smart contract, it knows about all that stuff and it can set it here. So instead of going to the smart contract and being like, what's that variable I want to read, I'm kind of in line just like, oh, I'm going to your contract and then I want the beneficiary. And I don't think there's any arguments. And let's hit save. And then we want to name it beneficiary. Okay? And it's yellow because we're not using it yet, but let's go down here and put a div. Ooh, what was that? I like that. Yeah, okay, but I don't want to use the address component yet. I want to show it off raw first, and then it will help us understand what we want to do next. Okay, so now we should be reading from our smart contract, whoever that address is that is the beneficiary, and we should be displaying it right down here. Let's go look and see how that looks. Ooh, looks good, right? Almost. It's working. It's displaying the beneficiary, but this is kind of a gross, it's kind of like a full address, a full hex address, kind of ugly looking. What you'd like to do is do ENS resolution and a lot of things like that. So what you do is, instead of just doing beneficiary like this, you wrap it in an address component. And this address component comes out of the box with Scaffold ETH. There's an address and an address input and a few others, and I can show you in the docs where to find those. If you go to components here, there's all those handy components. And to extend that, we have an extension system that uses a lot of other components, like the on-chain kit from Base. So if you wanted like a swap component, you could use the extension system to bring in the on-chain kit and just add that in too. So we have like low-level components, and then the extension system will have like some nicer level components. And Kevin Jones will show that off here in a little bit when I get done speed running this. Okay, so how is our front end looking? Let's go. We have, oh, doesn't that look so much nicer? Let's do that again. So, whoops. So this is like at the eye doctor, you know, number 1 or number 2? Number 1, number 2. Doesn't that just look gross? And then when we do just this quick change and we hit save, and this looks so much nicer. I love it. Okay, so we're displaying who the beneficiary is, and we know who the connected address is. And then, okay, now we need to, let's see, we want to write to the chain. And I think maybe we could, maybe let's just make a withdraw button first. I think that's the move. That's the move. So let's go back to Scaffold ETH docs. So now we want to write to our contract. We're able to read from our contract, but now we want to write to our contract. So what you do is you set up this like async contract writer, and that goes in with your hooks there, okay? And that's going to talk to our contract. It's already named your contract. Oop, we need to install it. Okay. And then write your contract async. Okay, so we've got this object now that we can write to. So then here is a button. I'm going to copy that button exactly, and I'm just going to use it. And let's go down here, maybe set up like some divs. Let's do a div first. There we go. Then the button. Then hit save. Okay, so what is this doing? It's writing to the contract, and it's calling set greeting. So we don't want to do the greeting, though. What do we want to do? We want to call what? I don't even know what. Set beneficiary, set greeting, withdraw. I think we want withdraw. Let's go with withdraw. Okay. And then there's no arguments or value. I think I can trash both of those. And let's see, call this withdraw. And hit save, and let's see if we have a button in our app now. Whoa, get out of here. Yeah, cool. Now we have a withdraw button. Man, my front ends are so ugly. Scaffold ETH does as good as it can to like make this look nice, but I just tear it up and it looks terrible. Okay, can I hit withdraw here? It can't because I'm not the beneficiary, right? Because Austin Griffith is the beneficiary. I need to set this dude as the beneficiary. And we'll make some front end to do this, but let's just go do it in the debug tab real quick just to test that this withdraw function works. Yep, it does. Okay, cool. So now we're reading and writing from our smart contract, right? We kind of tinkered around with our smart contract in phase 1, and we kind of built the app that we wanted to build in terms of the solidity. Like I said, you might come back and add some events, but you're pretty much done there. Then we kind of move over in the front end land, and we start tinkering with how we want our front end to look. We've read the beneficiary from the smart contract. We've used WAGME to tell us who the connected address is, and then we've written to the chain with this nice withdraw button here. So the last thing I want to add here is a little address input field that lets you put in a new beneficiary and save them. And I think, let's see, how am I going to do this? Maybe down here. Let's just make another div down here. It's kind of weird. Let's see. I want an address. I'm just going to go copy paste it from the docs. Just go copy paste it. Here we go. Normally, I would prompt the AI with like examples and just have it write it all for me. But let's do it this way. I want address input. Okay. So I want to grab this. Okay, it looks like there's a state. Oh yeah, yep, I want all that. I want that right there. So you have some kind of state over here. Boop. And then you have your address input right here. On change, it'll set the address. Okay, let's see how this looks. Do I need to install this? Yes, I think I do. Let's see how we're looking. Let's see what our app looks like now. Uh-oh, use state. We've got use state is not defined. We need to go to that use state from React and make sure we import that. Oh. Open Apple period. There we go. React. Bring it in. Let's go. Let's go. All right, how's our app looking now? Ooh, there we go. Okay. Ooh, there's a semicolon floating around there. I don't know what that is. I'll go get it in a second. But now you should be able to type in vitalik.eth, and you should get that nice ENS preview. You should get, boy, I need some padding. This app looks terrible. How do I do that? Maybe some like class name. Yeah, ooh, we might even center the div. What does that do? Oh, wow. Yeah. Okay, let's get rid of that weird semicolon too. I don't know where that's coming from. Right here. We don't need that. Okay, and I kind of like this class right here. I'm going to bring that and I'm going to give that to all these other divs just so this thing starts looking a little bit better. One for you. One for, maybe we do, let's do a div here and do that class name. Yeah. And then close the div here. Oh, I think it tried to close it for me. The AI can just write code better than I can. I shouldn't be doing this. There we go. Doesn't that look nice? We need a little padding, but I'm gonna go with it. Boy, this is a really ugly front end. Okay, so we have the withdraw. That's working. We have the address input. That's working. It's tracked in state. I think what we need to do is one more write function where we set the beneficiary. So we're going to need one more write function. I'm just going to copy paste. Actually, that's all good. I can just use that write async. So let's go get another button from the docs. Oh, here, I have it right here. I'll just copy this button here. Right, this dude. Okay, and I'll take the whole div. Okay, and we're going to put another button underneath this, and this is going to set the beneficiary. And then for the function we need, set beneficiary, and there we go. It wants to give us some args. That's what we want. Is address the thing that we're keeping in the state? It is. Okay, I think we might be happy. Let's see what we have here. Okay, well, it looks ugly, but let's see. Can we set Vitalik as the beneficiary? Boy, a little padding would go a long ways there. Yeah, it worked, right? Now Vitalik is the beneficiary. All right, let's try that again. atg.eth, set him as the beneficiary. There it is. Okay, so it's working. All right. And then if you are the beneficiary, like this dude is, then once that updates to that, you should be able to hit withdraw, and that should work. But if you're not, let's go back and do atg.eth again, set him. Now if I hit withdraw, it should fail, right? Because I'm using the burner wallet. Yep, not the beneficiary. Okay, cool. Just want a little padding here. It's just driving me nuts. Let's see, P, yeah, there we go. There and there. How's that look? Yeah, it's a little better. It's still ugly. Okay, and another thing we might do is only display the withdraw button if the connected address is the beneficiary. Like, we should probably only show this withdraw button if these two are the same address. And here's a great chance to just prompt the GPT to do this. But we could say something like, please only show the withdraw button if, let's see, what do we have? If beneficiary is equal to connected address, right? There we go. Let's go. Yeah, thank you. And then it's just going to give us the code, and we apply that and save, and let's go see now. Let's test it out. Okay, so it looks like that withdraw button is gone now. That's okay. But if we set us to the beneficiary, does the withdraw button come back? That's what we want to test. Yes, it does. All right, GPT, you got on the first try. Thanks, bro. All right, awesome. So this is kind of, we're nearing the end of phase 2. Basically, in phase 1, we worked on our smart contract, we tinkered with it, we went back and forth, we got our solidity right. In phase 2, we did a lot more React, kind of getting our buttons, things wired up, we're reading and writing from our smart contract. Phase 3 is now deploying. We want to put this thing out into the world. And to do that, we'll have to deploy both the smart contract and the front end. So to do that, we're going to need to yarn generate. And yarn generate will create a deployer account. So you want to be very careful with these deployer accounts. You really don't want to be like copy pasting private keys around. They really should be like living encrypted on your box. So when we generate this account, this is like a one-time use account basically. Like this account should only ever have enough money in it for me to deploy this contract once or twice. So there's my address. Then I'm going to do yarn account to show it. Okay, there we go. And now I'm going to send some money in there, and we're going to put this thing on a live blockchain. Let's go. Okay, let's see. I'm going to use a Punk Wallet app built with Scaffold ETH. Let's see, we had it on Optimism yesterday. Base, let's see if I have any Base in here. I think I'm going to deploy this to Base. Okay, so I just select Base, I scan my QR code, and I'm going to throw $1 at it, right? It should be enough. Shouldn't be too expensive. Ooh, time to retweet Shutterblock. I got you. Yeah, let's go. Retweeting on stage. Okay, so hopefully I just sent some money here. Actually, yeah, I did. Okay, let's do yarn account, and it'll even like give us our balances on the different accounts. And is Base in there somewhere? Localhost, Arbitrum. Let's just see. We're hoping I have some Base in here somewhere. There's only, oh, there it is. Yep, we got some. We have 0.0003 ETH, okay? So we've created a one-time use deployer account. We've put $1 in it, and now I'm going to do a yarn deploy just like I was before, but instead of yarn deploying locally, I'm now going to do the -- network, and I'm going to go with Base this time. Now hopefully this works, but let's see if it complains about anything. We may just put a smart contract out on a live network. That's looking pretty good, y'all. Okay, cool. So our app, though, still says hard hat up here. We need to get in and change our app over to Base. And what that means is the whole app is going to change networks. So right now, if I click on this dude's address, it's going to take me to a local block explorer. which is cool and nice for local debugging. But this is also really awesome. As soon as I set this thing to base, then all of my address components all throughout the app will now link to the base scan block explorer. Let's do that real quick. So I'm going to hit OpenAppleP and find the scaffold config. And from the scaffold config, I'm going to change it right here. And you can even do like a comma-separated list here. You can have multiple networks. Like you could deploy your smart contract to Optimism and Base and let your users pick which one they want to use even. It's pretty nice. But we're just going to go with Base. Now watch this. As soon as I hit save here, the whole app now switches over to Base. And it doesn't let me use burner wallets anymore. And that faucet is gone, right? By just setting that one thing from localhost to base, your app now knows that it's like, oh, it's time to sit at the big kids table. We're going to go use like our real wallets and real money here. And let's do that. Okay. Yes. There we go. Okay. So we are now talking to our live contract on base, but we're still at localhost. So a second step that we'll get to in just a second will be to deploy the app live to Vercel. But first, let's just tinker around and make sure everything's working on-chain correctly. So let's see. Can we set Vitalik to the beneficiary real quick just to prove that we can? And I'm actually going to pay real money to do this, right? I'm going to pay like, a fraction of a penny. No, more like 32 cents. Dang. Whew. There we go. And now, hopefully, Vitalik will become the beneficiary. I'm going to hit reload. I'm impatient. There we go. Cool. And it's working. Okay. And our withdraw button disappears too. Looks pretty good. Okay. So then let's, I don't know. Let's set me back to the beneficiary. And then maybe let's put some money in the contract and then withdraw from it. Make sure everything's pretty solid, and then we'll ship our app. You know what? Actually, I'm going to start shipping the app now because it takes some time. So kind of the commands, if we go through the whole stack of commands here, we did yarn install, yarn chain, yarn start. To get your account, we do yarn generate and then yarn account. And here we're going to do yarn. This is the best command out of all of them. Vercel YOLO -- prod. Like, please, do not check anything. Just ship it. And that's what we're going to go with here. Yes. Got to do the choose your own adventure here of like picking the scope and the account and all that. Ooh, it's very slow. No. Devcon 3. Okay, so that will take a couple of minutes to ship, but now that it's shipping, it's nice because we can go back and tinker around with these few mechanics that we were worried about here. So can I set me back to the beneficiary, basically take control back of the contract, and then let's maybe even send some money into it, right? Let's do a greeting that says, hello, Devcon. Nope, I'm gonna do hearts, 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 classic. Hello, Devcon, hearts, 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 and I'm going to send in some money. And technically, this money could be stolen. Like anybody out there could go to the smart contract, set themselves at the beneficiary, and hit withdraw. I don't think they'll do that, but maybe they will. Let's find out what happens. Okay, yeah, $3 to be had if you want to steal it. You'd have to go find the thing out on base scan or something like that, right? Like if we go look at the contract here, it's probably not even verified yet. But remember that contract component, all I have to do is click here, and it takes me right to the base scan, right? The correct block explorer for whatever chain you're on. And here is the smart contract, but it is not verified yet. Yep. Okay, so I would need to verify the contract before anybody is probably going to attack it. I don't think anybody is going to figure out how to attack it right now, except for maybe you guys out here, which kind of have the alpha on it. So please come steal it. Like I would happily lose my $3 to anyone in here who wants to steal it, because that means you guys are way ahead of the game and really paying attention. Let's go here. Devcon, hearts, hearts, hearts. We got money in here. Nope, I need to hit send here. Wait. Didn't I hit send there? Why isn't there any money in here? Let's reload this real quick. Okay, maybe I didn't hit send. I wasn't paying attention. Let's try one more time. Devcon. No, it's right there. It's right there. Hearts, hearts, hearts. Premium is true. Oh, man. What if someone already stole the money? Like, it's not in the contract. What? Yeah, someone did. Look at that. Look at this address. This is not my address. This is someone else's address. Someone got in and got it right away. Wow, that's really impressive. That's neat. Okay, well, someone stole my $3. All right. That's pretty awesome, to be honest. Like, that's really cool. So that's like probably like a bot that's like watching for contracts to get deployed and looking at the bytecode, and man, that's really cool. I don't even, that's so cool. Like, I'm like thinking about how, like, we could definitely defend this, right? We could set up a require statement here that says only, certain people could set the beneficiary. There is this idea of this owner, and we could say the owner is the only one that can set the beneficiary. Let's just do that. All right, so we learned a lesson here about the dark forest. Okay, so, you know what? I don't care. No, we're shipping it. This is more fun like this. Let's just leave it how it is. The app is going. Everything is good. Kudos to whoever's running that bot and taking my $3. I'm probably going to send them a couple more bucks here for a little bit. But check this out. So now our app is live. And you can go to Vercel and set up a domain on this thing. So within 30 minutes, you can kind of roughly crank out a smart contract, get a front end going, and then deploy the thing, not just to base, but also to Vercel. And there is a live URL. So yeah, within 30 minutes, we kind of built this whole app, and I'm gonna go donate another $3 to this attacker just because, I don't know, that's pretty cool. Let's see, what are they doing? Let's go look at this address real quick. Look at all those zeros. Oh, this is definitely some nerd. They have, how many is that? That is impressive. Yeah, it's like an MEV bot that has a bunch of leading zeros. That is so cool. Oh, it's a contract. We can even go dink around with it. Ooh, maybe not. Okay, anyways, let's set the beneficiary back to atg.eth, and let's see if it like front runs me or what it does. That is so cool. Here, I don't know why I have to keep hitting this. I don't know if I need to like hard code the gas limit or something. MetaMask is just not happy with me with gas. Okay. And now, hopefully, I am the beneficiary. And it shouldn't steal it right now, right? Like, there's no financial incentive for them to set themselves as a beneficiary right now. What they want to do is wait until there's money in the contract, and then almost like in a batch transaction, set themselves as the beneficiary and sweep the money all in one transaction atomically. And basically, like, you only do that if you, Portman! You only do that if you, can make the money, right? So the MEV bot is probably sitting there like, we're going to do all of these transactions, and we're only going to execute them if it works and we make money. And if anything else goes wrong or we don't make any money, don't do it, right? So as soon as I put money in here, it's going to disappear again, which is pretty cool, but not great, but pretty neat. Let's see. Man, really, I feel like we could, if a bot is that sophisticated, I might like start making this as part of my like curriculum, where actually you like know that a bot is going to handle something for you, and you can have them like be like rolling the dice for you in some game or something like that. I'm going to think about that. Okay, here we go. Oh, please take my money, Mr. All. Oh, it could be Mrs. too. Yeah, right. I'm going to say Miss Merce, all zeros. All right. Right. It needs to be, right. So it's costing about 30 cents to set the beneficiary, right? So then another transaction, maybe 60 cents. Like, it's got to be, within like $1 or something. We did 0.0001 last time, I think, and that was enough. Maybe we do 0.5 just to see. Let's see what this does. It would be really funny to like calculate it just right and see like at what point the bot takes over. But yeah, here I go. I'm going to donate another couple bucks to this bot probably. Okay, let's see. There's the transaction. And does the money stay in the contract or not? Let's see. I'm assuming it will be immediately swept if Yep, they're the beneficiary already. That is so cool. Oh man, I'm going to use this for something. That is neat. Okay, so this is kind of the stack. This is Scaffold ETH. This is how you can get started building apps. This is the way you would go about tinkering with Solidity. Kind of in our first phase, we used Solidity by example. We wrote the Solidity how we thought we wanted it. We left it very, very accessible and attackable, but you'll do a better job of that when you're building real contracts. Don't do what I do. Build a good contract in phase 1, and then in phase 2, we kind of built out the front end, and then in phase 3, we deployed the whole thing. So now, I think I'm going to hand it over to Kevin Jones to show off extensions in a little bit. But let me just like pause here just to see if there's any questions. Maybe we could do like 4 minutes of by 4 minutes. A couple minutes of Q&A. If anybody has any quick questions, and in the meantime, I'll hand it over to Kevin Jones, and he can do the same thing, but he's going to use an extension system, probably Graph or on-chain. Graph? Yeah, that's what. got to chill. Okay, any quick questions? Yep.
What was the command to deploy it? Can you show it again?
The yarn command to deploy? It was yarn deploy -- network base. Oh, the Vercel. Oh, yeah. Okay, yeah. And also, this is in the docs, but it's Vercel. It's yarn Vercel : YOLO space -- prod. And that's what shipped the app to Vercel. Yep.
Before when you said you piloting and wasn't verified yet, it sounded like you thought that would make it not.
Yeah, I did. I'm pretty impressed. That means that someone is watching base for contracts to get deployed, they're decompiling the bytecode, and they're looking for attack vectors where they can make money, and they're even doing this like batch transaction. Let's go see if he batched the transaction or not. It could. Let's see, where is it? Yes, you do. So, so when you deploy a smart contract to any live network, the code isn't out there yet. You have to go to the block explorer and upload your code, and then on their side, they compile it and make sure it compiles to the same thing, and then they display the code. So if I were to go look at like WETH, say it one more time? The block explorer needs to, so see how this contract has like the green check, and we can get in there and actually like see the code for what WETH, how it works. Yep. So they have to verify, right? Because like they couldn't trust you to do the verification. You can send any code to them, but it has to compile down to the exact bytecode that's on chain for them to display that code up here. Does that make sense? It's not free, I don't think. It's just like a really nice cloud hosting service. I think it's probably less decentralized. We're a bunch of cypherpunks here, and Vercel is great for quick front ends. You can even this code is all open source and forkable. So if anybody wanted this code or to dink around with it, they could just deploy their own front end if they wanted. So like you could create infinite copies of this front end. So to me, it's like good enough decentralized, but also like you probably want to, if you're hardcore about this, deploy your site to IPFS also and have it live in some kind of distributed storage that people can access without, even if Vercel goes down, you can have that stuff pinned in IPFS. But yes, Vercel is a hosting service. I think we pay for it. Build Guild has a paid account, but you can get started probably pretty cheap. Lots of guys can answer that question better than I can here too. We'll have a whole day of Build Guild people here, so just come hang out and ask them some more, and we can show you around for sure. Okay, any last questions before I hand it off to Kevin Jones? I'll be up here again after lunch, and we're going to do Speedrun Ethereum. We'll go through your first 5 apps on Ethereum. Yeah, what was your question? There is a verify command, but I think you have to have your API key, and I don't want to go digging through my credentials right now, but if I do yarn, let me try it. Yarn verify -- network base. Let's just see what happens here. My guess is it's going to say you need an API key. Yep, I think so. There probably is some base scan API that I need to put into my config, but I don't want to go digging through that right now and expose a key in front of everyone. But yeah, I think yarn verify probably without even anything on the network. Yeah, it's not going to work. Yeah, this is trying to do it locally. But yes, yarn verify is the command. Okay, how you guys feeling? Feeling good? You want to go? Let's go. All right. All right, thank you all. I'll be back in a little bit. We'll be in this room all day today. This afternoon, we're going to be playing a CTF, Capture the Flag. It's going to be awesome, highly technical. We're going to give away prizes, probably like thousands of dollars, $1,000. We're going to also give away a node. We have a pre-synced Build Guild node. So if you go to client.buildguild.com, we've made our own Build Guild client. It actually runs Geth and Lighthouse. And these exist kind of all around the world, and it's like this opt-in system where you can become a distributed RPC for Build Guild. But we're going to be giving some of these away. So you can get a box from us and take it home and plug it in, and it's going to look like this. It's going to have Reth and Lighthouse syncing automatically and lots of nerdy desktop stuff. Okay, thank you very much. We'll be here all day.
Thank you so much. Oh. Hello, welcome. Can you guys hear me okay? Yeah? Seems a little low, but that's all right. All right, cool. Thank you guys so much. My name is Kevin Jones. I actually work in DevRel for the graph, so I work on the graph protocol, which is totally appropriate because I'm going to show you guys the graph extension for Scaffold ETH and talk a little bit about the extensions. I'm also a core member of the Build Guild, do a lot of workshops with the rest of the crew here. And yeah, so that was an awesome workshop by Austin. He covered really all the basics of Scaffold ETH, so I won't focus too much on that, but we will talk specifically about some stuff that's on the actual doc site. So if we go to the docs, there's a section here for extensions. So you can come there. It gives you some basically like kind of overview of what the extensions is. You can have like a GitHub repo with the extension configuration, and then you can just execute it with this -e flag. And so there's a lot of like community extensions. If you go to, I think it's the Build Guild website. So if you go to biddlegiddle.com and you kind of scroll down a little bit, there's a section here, at least there used to be. Maybe it's on the Scaffold ETH website actually, let's see. Yeah, here it is. So Scaffold ETH, there's a whole area here where like check out available extensions. And we did a hackathon, I think, not too long ago. So there's a lot of really cool ones that have been built. The very first one was the subgraph one, which is really cool. It's basically got a, Scaffold ETH, one of the cool things about it is it's this very local development kind of environment where you're just like able to hack away without pushing anything to a test net. And so the subgraph extension is exactly that as well. We actually can spin up a virtual infrastructure of the graph on our machine, test our subgraph configurations just all locally using Hardhat. So we're going to show it off and show what it looks like. But there's a bunch in here, right? There's one for Ponder, if you prefer that. And then there's like ERC20. As Austin said, there's the on-chain kit, which is cool. It's got a swap extension. So yeah, and you could write your own. We'd love for people to build on that. If you go back to the docs and you go to extensions, there's a list of all the available extensions that we supported building, that the Build Guild has supported. But you can also get the list from the Scaffold ETH website. And then here, there's an explanation of how you create your own. So I personally have never created my own. It's definitely on my to-do list, but I think it's pretty easy. I think it's very similar to how you create a package with the npx command. You can also do that using this extension development utility. So you can come in here. You can either clone the repository, so you do need to clone the repository, which it's a special branch here. It's under the same Scaffold ETH account, but it's called Create ETH. So you can clone that Create ETH package, install all the dependencies, and then run this kind of like build script. And then there's a CLI that allows you to create new extensions. So the subgraph extension, or the extension system is really cool. It really allows you to kind of make these custom reusable environments, all built around Scaffold ETH, right? So let's just take a look at the graph one. So it used to be that we would have like a special branch of scaffold ETH, but we're moving away from that model, right? We're moving to this extension model, which was designed by the core Build Guild team. And it's, basically this create ETH extensions repository. So you can think of it this way. There's the create ETH package, which is the way that you install scaffold ETH with NPX, right? But then there's the create extensions, which is like if you want to build your own supported extension in the Build Guild community, you might do that. So we have all of our ones that we worked on here. And the very first one, again, was the subgraph extension. So if we come here and go to the branch and choose subgraph, there's this nice README that kind of explains it, right? This is a README I wrote, which kind of shows you exactly how to set it up. So anyone who wants to follow along can do this, but I'm going to actually spin it up and show you guys how it works. Show of hands here. Who is hacking at the hackathon? A few of you? Just a few, huh? Okay. So, there is a graph bounty. So one of the things I always tell people is you could qualify for the bounty with this package and use it as kind of like a good starting point. Who here has used the graph before? Who has created a subgraph? A few of you guys? A few of you? Who here knows what the graph does? A few of you. Some people from the graph are here, which is great. Well, let me kind of preface it this way first real quick, because I think it makes sense just to understand the context. This is not a talk about the graph, but it makes sense to why we would use this graph extension. Scaffold ETH is like this, right? It's got a front end, it's got a back end, it's got all this cool boilerplate code written, it's got these, all the proper packages you need to build and create a package or an app pretty rapidly. And it's really the quintessential way that applications on Ethereum have been written pretty much since inception. But there's kind of like this missing gap when it comes to reading data from the blockchain. Now, Scaffold ETH is really good. It has these really cool hooks and be able to get the data that you need, just if you want to read it directly from the RPC provider. But if you want to get lots of data, if you're building a DeFi application or if you're building something like an NFT platform with lots of users, the more users you have, the more scalable your data issue is. So using something like the graph is kind of like a solution to that problem. So you can think of it like this. We're still going to use Scaffold ETH, but we're going to use Next.js and Hardhat, and then in the middle, we're going to have this kind of graph infrastructure. So we're going to simulate this all inside of Docker. So the only difference here is we're still using all the packages that Austin used, but we have a layer that's going to run in Docker. So let's just spin it up so you guys can see. This is how you do it. So you just do npx create-eth at latest. And so we do npx create-eth at latest -e subgraph. So same kind of method. We just use the npx create ETH command, asks us what we want. What? My internet connection locked up. Did I do something? Uh-huh. Like a VPN? Oh, tether. Oh, I see what you're saying. I have a tether. Yeah, let's do this. Let's just try VPN. Almost got disrupted right now. That was very scary. I was like, I've never seen that error before. Okay, cool. So it's working now. Thank you so much. See, Build Guild homies got my back. All right, so it's going to do the same thing. It's going to give you this kind of choose your own adventure method, right? So we're going to do, I don't know, Devcon, sure. Hit enter, and same thing. We get to choose a package. We support both. I personally like Hardhat just because it's been around for a while, and I'm just so used to writing this stuff in TypeScript. But you might choose Foundry, like Austin said, if you want to write Solidity tests. That's the way to go. Or you might just not use the chain at all. Maybe you just want to use the graph for doing some data stuff. You could do that as well. So it's going to go through, install the packages for us. Again, it's going to scaffold out an environment. Now, Austin mentioned that Scaffold ETH is this kind of mono repo, right? It's got the Hardhat or the Foundry, and then it's got the Next.js package. Well, this is just going to give us one additional package, right? It's going to give us this additional folder called subgraph, right? And it's going to lend that by going through and basically using, this, where is it? Right here. Using all the boilerplate code that comes in here. So if we go to extension and we go to packages and we go under there, you'll see that there's this new subgraph folder, right? So let's give it a second. On VPN, it's probably even a little bit slower. I'm using a cool tool called Tmux, just lets me split my screen up. This doesn't obviously need to be that way. We can just do that in different windows, but let's do that. So Devcon, cd Devcon, okay, cool. And while that's loading up, let's just take a look at the code, because it should at least be there for the most part. Okay, so we see this packages folder, and then we see there's an additional folder. So in this case, we have this cool extension that we can use called subgraph. We can go in there and we can start to see what's available to us. So it's the same exact thing for Scaffold ETH. We have the contracts folder. We have the same exact sample contract. And then on top of that, we have the Next.js folder with the same exact code. The difference is we also have templated in some cool additional code. So an example would be, like in this case, we wanted to have this like subgraph route. So Scaffold ETH uses the app router functionality of Next.js. So we have this subgraph folder. And then inside of there, we have this dedicated folder or this dedicated page with all of the code for the front end. And you'll see what this looks like in a sec as soon as it's done installing the packages. It's a little slow right now. And then let's take a look at the graph. So without doing a full overview of the graph, I just want to kind of explain, like within a few words, what a subgraph is. A subgraph is really just an API, right? It's basically an API layer for any kind of blockchain data, right? It's this middleware layer. And so we basically want to create what are called subgraphs to organize the data. So just like we have a contract here called your contract, and we have this concept of updating the greeting, which Austin showed off, right? Where you can like update the greeting, pay some gas, pay some value. That greeting has an event, right? So it has this basic event. So that event says who set the greeting, what the greeting was, whether they paid some value or not, true or false, and then what that actual value was. So this event is kind of like it's like a log on Ethereum, right? We want to keep track of something, and we probably want to display that in our front end. So we could just query that directly using Scaffold ETH. There's a hook for that. If you go to scaffoldeth.io and you go to interacting with your smart contract, there is a event history, and then there is also a watch contract event. So there's two ways you can get information. Lots of information, or if you want to just like watch all of the events that come off, you can also do that. So it's easy to get like small bits of data, but if you want to get like all of the events that happened since you deployed your dApp, maybe you want to get thousands of events, it's not effective to use something like this because it's going to be too slow, right? So we can take this event data, and as it gets emitted off of the blockchain right here, right, we can index it. That's what the graph is. It's an indexing protocol, right? So if we go to that subgraph folder and we go to the subgraph configuration, it's already predefined for us. This example comes with the network we care about and the address of the smart contract. It also comes with the concept of what are called entities. And again, we're not going to go too far down that rabbit hole, but it's how we want to store the data. And then we have this handler. And all of this stuff, it's three files. It's the configuration file, it's the schema, which is like how we store the data, and it's the handler, which is like how we process the data, which is runs an assembly script. You don't need to understand that stuff, but that's what a subgraph is. It's those three things created to process data. So if we want to write our own custom subgraph, we can, but we're just going to use the one that comes with this package for simplicity. We're not going to change the contract at all. We're just going to show how everything works. So Scaffold ETH's done installing. So let's go up here. Let's go into the Devcon folder. Let's do yarn start. Oh, sorry, yarn chain, sorry. Yarn chain, yarn start, and yarn deploy. Now, the difference with this package, because we have a third package that we're using, the subgraph package, we also want to have another window, right? So we still need our chain, we still need our front end, We want to do our deploys in this window. This last one is where we're going to simulate the graph in Docker, okay? Now, you don't need to know what Docker is, but Docker is basically a virtualization layer that allows you to run what are called containers. It's kind of like running virtual machines, but they're very, very small. And so we're going to use the the Docker's power to do that inside of what are called Docker containers. Again, you don't need to know that, but to do that, all we need to do is do yarn run-node. So that's going to, there's like a file that's on there called a Docker compose file that has all the configuration defined for creating a graph node on your machines and all of the infrastructure you need. So you need an IPFS node and you need a database, Postgres database. So it's pretty much all configured. You don't need to change anything. So we're doing that now. We're spinning up everything inside of Docker. So you need to have Docker installed. And that's just one example of one of the extensions. I think it's the most relevant, especially if you're going to hack at a hackathon and you want the graph bounty. Who doesn't like bounties, right? So use the graph one. So you know it's working, at least the graph infrastructure is set up when it says downloading latest blocks from Ethereum. So we have right here. So that basically means that the graph node, so graph node is the thing that processes data. It's what all the indexers run. It's a Rust-based implementation of like data indexing. That is all running when that says ready to download data's blocks. So we have our chain, we have our front end, we have the graph running. Now we just need to deploy our subgraph. So we already have a subgraph that's here. And this subgraph keeps track of all of the events that come off of the greeting. And when those events happen, it takes in the data types and it processes those over whatever network we want. So this is localhost. It puts those data type as objects, or I should say values, into a database in a certain data type, which are these. And it basically stores them and makes them available via GraphQL. So that's the power of the graph, is it creates an API for event data, which is super powerful. And it does that using assembly script mappings, right? And so if you come into this assembly script, we'll see that nothing's actually been generated yet. So we need to generate these types. We use assembly script with the graph, which is a subset of TypeScript. So it's kind of like TypeScript, but it's a little bit more simple. You can't do like imports of just standard TypeScript libraries. It needs to be an assembly script library. But it's super powerful in the sense that you can use the type safety of your imports. So we need to generate these. So let's go to scaffold ETH. So if we go to scaffold ETH, and let's go to the subgraph extension. By the way, how much time do I have? Anyone know? No? Like 30 minutes, 20 minutes, something like that? Okay. If I need to stop, just let me know. All right, so this subgraph tab here is this new tab we get, right? Because we're using this new repo. We've kind of templated in some code, and so now we can do some additional stuff. So you'll see on the bottom there's a very basic README that shows you how to get started. So to spin up the environment, you do yarn run node. I already did that. To create a subgraph, you run yarn local create. To deploy your subgraph, you do yarn local ship. To build out assets for your front end, you run yarn graph client build, because we use graph client. And then to clean up the database, if you need to, you can clean node. So it tells you exactly what you need to type. So let's do that. We don't have any data in our contracts. Maybe we make some, let's do some things real quick. Let's send some greetings. Let's do yo Devcon and send. We don't have any funds. Let's get some value. All right, so Kevin was here. I'm just sending a couple things, so we have that. Thank you. Cool. So I've sent a couple things, but they're kind of like lost in the ethos of like Ethereum. Like, how do I get that data? Well, we could use the hook, right, to get that data. But if there's like thousands of events that have happened, well, it's going to be pretty clunky, right? So let's use the graph. Cool. So the next thing we need to do is we have the infrastructure set up to simulate the graph. We're going to do a yarn local-create, like this. Boom. So that's going to create like kind of like a skeleton environment for our subgraph. That's just like a very simple command. You need to type that once. Then we're going to actually like generate the code, build the subgraph, and then try to ship it with a few commands. So we do that by doing yard local ship. So what this does is it generates all the types for the subgraph. It builds the subgraph into a WASM module, right? Because we use WASM in the graph. And then it ships it to the graph node instance. And it puts all of the stuff into IPFS that it needs to, and it creates a GraphQL API endpoint for you, and it just does everything using the graph infrastructure. And then it asks you what version you want to use as well. So just like you'd have versions in your software, your subgraph evolves over time. You add a new event to your subgraph, then you add a new version, right? So let's do 0.0.1, hit enter. It's going to check if there's any errors in the code, right? If there was like something missing that was not properly generated, then it's going to give you an error. But it deployed successfully. We can see here that the graph is indexing data. Cool, let's go back. So first of all, we'll go to the subgraph tab, and there we go. We get the commands or the data here on the bottom. I'm kind of surprised it actually has the data already. If you make changes to your subgraph, you might have to regenerate the types, which is doing this. We use Graph Client, which Graph Client is like a front-end framework. It's similar to like Apollo or I forget the other one, Urkel. I like Graph Client because it's very simple. You can do some interesting things for like working with GraphQL. It's just a little bit more optimized, I think. So we use Graph Client, so there's this additional command that you might need to run to generate the types. But as you can see, the data is already there. And so if we look at that code real quick, let's go to the Next.js folder, app, subgraph. There's the main subgraph page, and you'll see here we create a table. So we do this greetings table, which is down here at the very bottom, right here. So we go to greetings table and go to the components of that greeting table. Here it is. So we use, using some state where we have this kind of query that we do by calling a get greeting document, which is probably somewhere in here. Here it is. It's just a GraphQL query. So if you're not familiar with GraphQL, GraphQL is like a query language that allows you to query exactly what you want in a very optimized way for front ends. And so we are using the graph for that. And so we're using this kind of custom query that gives us all of the data back in one single HTTP query, right? Instead of calling the RPC over and over and over and over and over again to get all the events, we're just doing it in one simple query. And we're also getting the greeting count and the address of that person that sent the greeting. So we're getting a lot of advanced data just with one query, right? And so, yeah, so what else do I want to show off real quick? So, and also it's going to give you this like URL, which is right here. So let's grab that real quick. Real quick, I want to show that off. So if we go to, boom, 12 minutes. I have enough time to actually probably go over the subgraph config if anyone's really interested, or I can answer questions about extensions. But let's first of all show this off. So this is called GraphIQL. GraphIQL is kind of like this way that you can like test your GraphQL configuration. So again, the graph uses GraphQL heavily, right? That's what we rely on for people being able to access the data in a reliable way. So if we click Explorer here on the left, and sorry, this might be hard to read, but we can see that there's these data objects that match what's in our schema. So these are kind of like what's in the database, basically. So if we look at the GraphQL configuration for the subgraph and go to the schema, these are going to match. So in our case, we have this greeter, and so we have greetings that happen, and then we have senders that send those greetings, and we kind of like build a database for all that stuff. And so all this data is what we're storing in Postgres and exposing via GraphQL, and that's what you're going to see over here is these entities. So if I want to get all the greetings, maybe I want to get like the first, I don't know, 1,000 for some reason, and I want to order them by the when they were created, and I want to do it descending, and I want to skip over the first 100 for some reason, or maybe the first 1,000. You know, you have a lot of flexibility here. I want to know when they were created, what it was, the ID, and I want to know who sent it, what their address was, and how many they've sent. And then I can hit play, and I can get that data back. That's not working. Oh, because I skipped over. Let's not skip. There we go. So because I skipped the first 1,000, there was no data. But here we go. This is all my data. So this is a GraphQL query that I'm creating, and this is the response that I'm getting. So what we're parsing in our front end on over here, in here, is the data that's coming back from the JSON response over GraphQL. Cool. Hopefully that wasn't too fast. That was good. So I can also talk a little bit about the GraphQL configuration, but why don't we pause for a second and see if anyone has questions first about the extension system or about the graph or anything that I talked about right now so far. Any questions? Bueller? No? Okay, then let me talk about the GraphQL a little bit, the subgraph configuration a little bit more. Definitely, we would love for people to build cool extensions. So if you're in the crowd and you are working on a protocol that can take the scaffold ETH and create an extension for it, come talk to us. We'd love to hear what you want to build, and we can get it listed maybe on the docs. But yeah, please let us know if you think this extension system is useful, and if you would like to see any features or if you want to see a cool extension built, let me know. But let me talk a little bit more about the graph. So, because I think it's probably the most confusing thing of everything I just talked about. But I want to cover this part a little bit more because I didn't really go too much into this assembly script. One of the powerful things about the graph is it allows you to do some interesting things during the time that an event happens. So the primary way we get data is events. We also have the ability to do what are called substreams, where we can get more block data. But in this case, the cool thing about assembly script is, again, it's a subset of TypeScript, so it's pretty easy to understand, but let's walk through it a little bit. So when we write our contract, just like Scaffold ETH generates the ABI, right, to be able to interact with our contract, well, the same thing goes for the graph. It needs the ABI as well. So we take the ABI, and then we generate all of the assembly script types that we need and store them into these files. So in this case, there's a generated folder. It has the name of the contract, and then it has the schema types as well, so how we want to store the data. So this is kind of like how we want to read the data, and then this is how we want to write the data, right? So these are the types. This other thing here is what we want to do with the data. So we use the graph TS package to, maybe we want to read in addresses from the thing and store them a certain way. In TypeScript, we need this package, right? So that's why in this case we're using the big int package to do numbers, to use big ints. And so in this case, we only have one function that the contract is sending, and so we have this ability to, one event, the greeting change event. So we take in the event here as part of the function, right here, greeting change, and then we create a unique identifier for the values of that actual string. So we do that by converting it to a hex string. Then we try to load it in the database. So we try to see if it's available. If it's not available here, if it's the first person whoever has sent a greeting, we just create a new one, right? And then we actually set who that person that sent it is, what the timestamp was, and then we do here, this is where we use the big int package to actually set the value for the very first time as 1, right? So we do some interesting stuff where we're actually storing the greeting count off-chain, right? We're not storing it on-chain. So the graph is really good for that, because if you have stuff you want to process, DeFi-related metrics, and you want to just store that in an easy-to-access way, that's where the graph is very powerful. And then if this person has come in and sent a greeting before, well, they'll actually have a count of 1 plus an additional 1. So it'll count that and add that too, right? And then the same thing goes for the greeting. We create an identifier for the greeting, create a new one using the string, the hex string, and then we set all those variables for the greeting, the sender, the premium, the value, the timestamp, and the transaction hash. And then here's where all that data gets saved. So it's kind of simple. And the cool thing about the graph, actually, if you use the CLI, it will generate all this stuff for you. So you don't need to write this stuff, but it's good to understand how it works. Cool. All right. So I know that part's probably a little complicated, but at least you guys get an idea of why you would use the extension, why you would use the graph extension, and yeah. Any questions at all? There's got to be at least one question. Come on. No? 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 Yes.
What is it that most excites you about this project and the new things that it enables?
Scaffold ETH or the graph?
The graph, the graph.
The graph. Well, the graph is great because you know, it really allows you to you know, improve the usability of the data from the blockchain, and so you can build some interesting stuff. I think what I'm most excited about is, you know, the advancements that we're making in indexing with like substreams, and yeah, just the network's getting, the network is very secure, distributed, decentralized, and we're like sticking very much to that ethos, right, where we believe that decentralized is super important. And so about, I don't know, it was 6 months ago, maybe not that long, we used to have a hosted service. We've completely moved away from that, and everything is on the decentralized network, and we're moving to continue that and focus on decentralization. So.
Thank you.
Yep, thank you. Cool, we got 4 minutes. Any other questions? Yep, back there. Let's get you a mic. Back there, green sweatshirt.
Okay, so first one, maybe it's because I don't know the graph and so on, but you can run mutations like in GraphQL, or is only for indexing data and fetch from the blockchain?
Sorry, I missed the first part. Can you say it again?
Yeah, in GraphQL you can do query and mutations, and here in the graph you are able to run mutations in the same way, or
You
it's
said
only for query?
computations?
Yeah.
Yes.
Okay.
Yeah. So you can essentially do like in there. I mean, I'm doing like a plus, or I'm just adding some stuff. There's time series data you can do with the graph, where you can like have like something happen over a certain period of time and aggregate. So there's some stuff you can do automatically with some base stuff. But yeah, it's more. Yeah, you can do computation. You just can't do like. You can't like, it's not an oracle where you could go out and like fetch some information and get that back. It's just stuff that you can do locally inside of assembly script and process and store.
Okay, and the second one, how much is auto-generated by the ABI? Is only the types from the schema, or also in the handler we are auto-generating on?
Yeah, so if you use, so that's a good question. So the thing is, it won't generate it won't generate all of the assembly script code for you. It will just generate the types. But the CLI, like the graph CLI, if you go to thegraph.com and install the CLI, that will read in all of the types and then build out a very basic kind of one for you.
Okay, thank you.
Yeah, good question. Cool. Any other questions? No? Awesome, cool. Thank you guys so much for coming. We're going to be here. We might take a small lunch break, I think, soon, and we will be back here later. So thank you so much, guys. Appreciate you.
I think they do have a Q&A here where you can scan this QR code and ask questions. So if anybody wants to, you can scan this QR code and it's going to show up right here on the screen. So feel free to ask more questions here. But we're here all day, and if you find any of these black shirts, you can ask any questions. I think now we're going to take a break, though, right? It's a lunch break time. Is that right? If the QA shows up, we'll answer it. Yep. If questions show up here, we will answer them. But yeah, don't feel too much stress to do that. The key is we will leave this up for 10 minutes, but we'll be here all day. And I think next after this is a lunch break, and then we'll be back and we're going to do building your first 5 apps on Ethereum, and then the CTF will begin. Sometime around 2:30, I think we're going to start the CTF. And there's thousands of dollars in prizes. We're giving out a node. It's going to be difficult, though. It's going to be a hard challenge. It's easy, but then it gets harder. And we'll explain more of that this afternoon. But yeah, feel free to ask questions. We'll be here all day. Go have some food. Come back in an hour or so. Do we know when we start back up again? 1:15? Perfect. Come back at 1:15 and we'll be building your first 5 apps on Ethereum. Possibly, maybe even Edda will do a presentation. Yeah, some of this. Oh, we've got a POAP here. Come scan this to get a POAP. Yeah. But thank you very much. We'll see you guys around. We're here all day. Thank you. Yo, what's up? I'm Austin Griffith. Thank you for coming to the afternoon session. I've done a bunch of morning sessions. We built a bunch of things already. We've done too many Scaffold ETH sessions already, and this is going to be another one. We are definitely like wailing on this beginner to intermediate content. If you are a builder, go to Speedrun Ethereum to learn how to build on Ethereum. This will help you with your first 5 apps, and we're going to speedrun the speedrun today. I've written a bunch of code. This will probably be a little less code writing and more just like going through the tutorials and talking about some of the aha moments you have along the way. Just to like zoom all the way out, we are the Build Guild. We are focused on developer education and tooling. Our main tool of choice is Scaffold ETH, and we use that to build a bunch of things. But that is also the heart of Speedrun Ethereum, which is our curriculum. And we're going around the world teaching people how to build on Ethereum, and anybody can just go to Speedrun Ethereum and get started today. And we're going to kind of just speedrun the speedrun today. I'm going to go through the challenges and just kind of talk through the kind of the aha moments you'll have, but hopefully you can go home and speedrun Ethereum on your own time and really kind of go through this at your own pace. But I'm going to go through it quickly just to kind of cover like, oh, here's the stuff to look out for, basically. Let's do just real quick, if you guys could give me a show of hands. How many of you have deployed a contract on mainnet before? Oh, yeah, we got 5 or 6 mainnet deploys. All right, how many of you have deployed on an L2? Actually less, I think, right? Less people? Okay, we're going to change that today for sure. We got to get you ready for that. Scaffolding, I deployed one to base earlier, and someone attacked it, stole my money. It was pretty fun. Okay, how many of you are software developers? Okay, look at those. I would say that was almost all the hands. Oh, I just got goosebumps. I'm excited. Okay, this is awesome. So I'm going to just do this speed run, probably 20, 30 minutes. I'm going to speed run the speed run, and then I'm going to hand it off to Etta, and she's going to do, I think, like an NFT build, right? Cool, awesome. Okay, so just in case you've missed me shilling Scaffold ETH, I've been shilling it all week, but it's a really great tool for prototyping, but also deploying to production. It's really nice because you can make small changes to your smart contract, and those changes are sort of represented live in your front end. So you add like a new variable, and boom, it shows up in your front end. And then say you set up a require statement that says only the owner can get into this function, and then to go test that, instead of writing, and eventually you will write lots of tests, but instead of writing all of those tests up front, what you can do is just create a burner wallet and try it as the good guy and make sure it works, and then try it as the bad guy and make sure it doesn't work. Scaffold ETH gives you that opportunity to try it, and it lets you tinker and test your assumptions. Okay, but today we're using Scaffold ETH within Speedrun Ethereum. And let's just look, we're just going to look at each one of these quests and go through these. Then I'll hand it off to Etta, then we'll do a Q&A. Maybe we'll do a quick set of questions before, yeah, I'm going to do that. I'm going to do like 20 minutes, then we'll do 5 minutes of questions, then Etta will take over. Then there's like this Q&A thing where they put up a QR code and you shoot it and ask like anonymous questions or something, but we might get to that too at the end. Okay, so building on Ethereum, here we go. The very first tutorial kind of points out that you probably need to have some solidity already. If you don't, if you're a coder, I saw all of those hands. There's a lot of coders in this room. It's basically everybody. If you're a coder, you can go to Solidity by example, or just go to the Solidity docs, and you're going to pick up the language pretty quickly. You're going to pick up the primitive data types, you're going to pick up the mappings and arrays, but just like go through this and kind of learn these concepts. For instance, Etherverse Way is a thing that we'll talk about today. There's a few other just kind of like aha moments you have, but you gotta first get the syntax. And so you can get the syntax from the docs, or you can get it from Solidity by example, or you can just prompt Cursor to write it for you too. Okay, so that's the basics. Also, there's a Web 2 to Web 3 series that can help you get your wallet ready and do some of those, first beginner actions. You know what? How many people have deployed to a test network? So the mainnet was 2, okay. Yeah, that's like 50, 60% of people have deployed to a test network. That's really great. Okay, so with that in mind, I'm probably going to double speed run the speed run. And I don't want to like bore you guys too much, and we can really get to the heart of building something with ETA. And then after this, let me make sure I shill this. The live stream will actually shut off, and we're going to do a capture the flag. And knowing that there are so many good devs in here already, I would recommend sticking around. It's going to start at 2:30 and it's going to go till 5:30. There's going to be these 12 flags in this NFT contract that you'll mint. We're going to give away $1,000 in ETH to the winner, $500 second place, $250 to third, something like that. I think the prizes are here. Yeah, there we go. But we're also going to give out, we have fully synced Ethereum nodes. We have this thing called the Build Guild client, where you can run a Build Guild, you can run an Ethereum node with a single line, and then we've been syncing nodes ourselves, and we bring them to these events. So the winner will win a fully synced Reth and Lighthouse node. Not a staker, like it doesn't have 32 ETH sitting on it, but it is a node that you can like run an indexer against or something like that. Also, if you are interested in running one of these nodes, we're looking for more node runners, specifically in South America, Africa, and Southeast Asia. We only have a few of them here, and we're trying to get these numbers up. So come talk to me after if you might be interested in running one of those. You might just get a free node that we send you. We don't have that many, but we have a few that we synced and we brought. We'd love to get some more participants. But that's for the CTF. That starts in a couple of hours, about an hour and 10 minutes. But first, let's speedrun the speedrun at speedrun speeds. So the very first challenge that you'll take on with Scaffold ETH is just a simple NFT contract. You don't even have to write any code. It's more about just getting your environment calibrated. You'll clone down this repo, you'll CD in, you'll check out that first branch. I'm going to bring this up because I want to start looking at this stuff in Git. I want to have that up. But this one's super simple, and it kind of goes through some of the basic concepts that you get from Scaffold ETH. For instance, burner wallets. You've probably heard me talking about burner wallets if you've been to any other session, but they're really great for local development. If you're building something locally and you need to make a bunch of transactions, it's way easier if you have a local burner wallet, and just every time you hit a button, it just makes a transaction, and you don't have to like have the pop-up and have the chain ID set with MetaMask and all that stuff. So burner wallets are another one of our little secret superpowers built into Scaffold ETH. And it has you, go to the faucet, load up your burner wallet, and then I think it has you even like send it around, right? In Scaffold ETH, you can open up multiple windows. And since that burner wallet has a private key and local storage, you can open up an incognito window, and it's like a whole new account. So if you ever need like a bad guy to try to see if he can, do something in the only owner block of your code, you just bring up a burner wallet, fund it, and then go try it. And then you go to your good guy and have him run and make sure it works for the good guy, fails for the bad guy, right? That's how burner wallets are really handy built into Scaffold ETH. So I think what you do is you get in here, you go to the faucet, and you get some ETH, and then you go ahead and mint these silly little animals. And then it has you send them around. So you'll create another account, and you'll send one of the NFTs to the other one. And you just kind of, it's really nice. It's like this, it's like a Goosebumps moment when you like hit send and it disappears over here and then a little buffalo pops up over on the other one. It's a lot of fun. And then it'll have you deploy it to, I think, Sepolia or maybe even base Sepolia, Optimism Sepolia, something like that. Yep, looks like Sepolia there, yep. And I think there's even a second test net on this, so you don't have to use Sepolia. I think we have a second, I think it's base Sepolia, but I don't know. Yeah, I don't know. And there's some side quests here, but that's the first challenge. And then what you'll do is you'll hit submit challenge. You'll put in your site. So you're going to deploy a live site that lets people mint NFTs on Sepolia, and you can run through this pretty quickly. Like a good builder could run through this first tutorial in like 20 minutes probably. So if you're a decent builder, you can probably dive in and actually like put an app out live within an hour. So you'll put the app URL there, and then you'll put your smart contract URL there, and we have an auto grader. So the auto grader, it goes and I think it downloads your contract and runs it, or maybe it goes and talks to your contract on Sepolia and makes sure everything works correctly. So each one of these challenges are auto graded with like a testing system, so you can kind of like level up as you go through each challenge. not really a whole lot of aha moments here. It's more like we're building up the base knowledge, right? So let's go to the next challenge, and that would be the, nope. Go to challenge 1. And yesterday I went through and built this one fully during a video. You could go look back at that one from yesterday. I think it was maybe called the same thing as this. But yeah, if you go to the Devcon schedule, search Austin, it's going to be like the second video there, and I go through the staking app. But let's speed run through it right now, just kind of looking at it. So I think this is probably the most important challenge. I would say the DEX is the most important challenge, but this is the real like heart of it. This is the beginning of like figuring out what kinds of things you want to build on chain and what kind of things like belong on chain. And I think a real aha moment, you know, you are deploying these apps that live forever. They have nation state level hardness, credible neutrality, but it really starts to make sense to me when I think of an adversarial group of players trying to coordinate. They want to coordinate. Maybe in this case, what we're going to do is we're going to get everyone to pitch in like 0.1 ETH, and if we get enough ETH put together, then we'll be able to go do this second action, like go buy this thing or invest in something, right? And what you need to do is build the smart contract in a way that they can't grief each other, they can't steal each other's money, but if they do choose to coordinate, they can coordinate. And I think that's a really powerful mechanism. And so you'll write this staker.sol, and you'll build a stake function, and you'll allow people to stake money into your contract, and you'll need to keep track of each person's balance, because if they don't end up coordinating correctly, then you'll have to refund everybody, and you need to allow everybody to be able to withdraw from the smart contract. So that's kind of like starting to sink in, like what kinds of things you might be putting on chain. This is kind of like a coordination mechanism with people that don't totally trust each other. It's slightly financial, but doesn't have to be. But you have to write all these rules. And I think one of the first aha moments for me is that none of this is automatic. When you think of blockchain or DAOs and autonomous agents, you just kind of think that there's like this magic thing that is handling a whole bunch of things in the background. And it certainly is a magic technology. But to make something happen on chain, someone has to make the transaction happen. And it's not like the smart contract is working in the background and doing things, right? The smart contract does what it's supposed to do, but someone's got to make a transaction against the smart contract to get the thing to work. So in this particular build, you're kind of building a state machine. If we want to imagine a state of, so there's this open period, right? And there's, at this point, anyone can stake. Anyone in the world can stake in this open period. And then at some threshold, at some time, maybe timeout, I don't know, what do we call it here? Let me make sure, deadline. So at some deadline, you need basically the contract to be ready to go into the next state. So you sort of have this open staking period, and then at the deadline, you set up an execute function that checks to make sure that the deadline has passed and that no one else has run execute yet. And then in that execute function, we need to check and see, did we get enough money in the contract? So there's an open period, people are YOLOing in money, we have some threshold that we need to get to, and some deadline of time that we need to hit. And once that deadline of time is hit, someone's got to poke the thing, and if they hit the button, or they make the transaction, and there's enough money in the contract, we move into kind of what we'll call the happy state, where the money actually gets invested wherever we want it to go. In this case, there's just like an example contract, and it moves the money into the example contract and calls a function on it. But that contract could be anything. You're kind of just imagining that that is something more advanced. Maybe you're buying an NFT or something more fancy. But so you're open state, you hit the threshold, or you hit the deadline, you check to see if the money is above the threshold, and if it is, then you're in the happy state, you move that money into the contract and you trigger the next thing. But if you didn't get enough money together, then you need to kind of go into maybe the sad state or the withdraw state. Some people have already YOLO'd money in and you didn't get to the threshold, so you need to, basically you have this open for withdraw. And the open for withdraw is kind of another mode, and that means anybody who has put money in, and now that we didn't get to the threshold, and now it's withdraw time. Now they can get in and withdraw their money back, basically. And that's kind of how these apps work, right? They need to kind of think of it like a state machine. You need to make it so we're not sending the money back to everybody. They have to get in and withdraw it, right? Because there's gas involved with that, and we're not going to run that system. So that's kind of the best like quick first build in Ethereum. Like this will be, I guess if we call the NFT app your first build, this will be your second build. And this build is really going to start illuminating the kinds of things that you want to put on chain. I think you end up putting it out on, Sepolia, and you basically deploy a staking app, and you learn along the way. So the next challenge is the token vendor. This will be your third app. And the token vendor really leans into ERC20 tokens. If you have ever minted an ERC20 token, you know that there's this transfer function, but there's also this approve function. And when you want to actually send a token into a smart contract, you don't just send it and it does stuff. You actually do this really weird thing where you go to the token contract and you approve the smart contract to take the money. And then you make a second transaction on the smart contract that says, hey, I've approved you to take my money, please do so, and then do some other things. And so it's a kind of a complicated thing to get your mind around at first, but that's what you'll do here. You'll deploy your own meme coin, basically, and then you'll make a vending machine smart contract that lets people buy that token at some exchange rate. You'll say maybe 100 tokens per ETH, and then they get in and YOLO some ETH, and then you send them some tokens. It sounds simple, but it's actually pretty tricky if you think about the different transactions that have to happen there and how these different smart contracts are interacting with each other. Let me see, I think the approve pattern is a big one here. Contract-to-contract interaction is a big one here. Just this idea that like, I think it says it right here. Like smart contracts are kind of like always on vending machines that anyone can access. I think that's just like a really cool way to think about it. It's like a vending machine in the sky that anybody can get to. That's pretty cool. And not even like nation states can censor it. That's really powerful. Okay, so those are your first three builds. Your fourth build is going to get a little gambly. It's going to be a dice game. And so the dice game really shows you how randomness on a public deterministic blockchain is kind of tricky. You can't really get randomness in the way that you might think of when you just go to like, hey, JavaScript, give me a random number, right? You can't get that from the EVM. It doesn't do that. But what you can do, and this is not a good idea, you can use the previous block hash. So there's a lot of entropy in the block hash because it has to do with like proof of work mining, and now it's validating and different. But it's basically a random string of hex characters. And so you can use that previous block hash for a very insecure form of randomness. And there's really cool ways to do randomness on chain with oracles and other ways that even like, we have this really cool way where you submit a previous header and it uses the block difficulty, which is now randao. So there are like very good ways to do randomness. This is not one of them. This is a bad way to do randomness. Basically the way it works here is you're going to put in like 0.1 ETH, and it's going to roll the dice, basically just looking back at the previous block hash and doing a mod of that, like mod 6, and it's like a 1 die roll, right? But if you win, you'll win like 6x back. If you lose, your money stays in the contract. And you can play the app, and you could probably load it up with some ETH, and it would play for a long time, but this thing is attackable. You can attack this by creating a second attack contract. I think it's called rigged roll is what we called it. Yeah, you build a rigged contract. And the way this works is the smart contract knows about the other smart contract and knows how it's deciding. It knows, okay, if we're on block 8, we know that this guy's going to be looking at block 7 and doing a mod 6 on it or something like that. So you basically recreate that math in your rigged contract, and then when you go to roll, you basically only roll if it's a winner. And so you can basically drain the dice contract with this rigged contract, and that'll be your third or fourth build. That'll be your third build? Where are we at here? That'll be your fourth build. All right. Let me see if there's any other little aha moments in here that I want to talk about. A really fun game, though. You get to roll this die, like you got all these cool, this Scaffold ETH makes it look cool. And the Build Guild team has done a really good job designing this, making it look nice and making it flow really smoothly. Some side quests in there. Looks like you end up deploying it. Contract verification. Looks good. Go do this at home. You'll learn a lot. All right, the fifth app, and I think the most important, and then I can hand it off here in a little bit, is a DEX. And a DEX is a way to swap. It's a decentralized exchange. It's a way to swap between some token and ETH, or maybe token to token. But the way this worked before was like an order book system. If you wanted to swap with someone would sign a message that they would be the maker, and then they would be looking for a taker, right? And the maker would say something like, I have 5 of these tokens, and I would like 1 ETH, and I've signed a message. And that goes into an order book, and then someone else could take that message and submit it on chain and send their tokens in and get the ETH back, right? So you could swap, but there's like this centralized order book there, and that order book can go down, that order book could get regulated. There's a lot of reasons why the centralization sort of falls apart. You have this really awesome decentralized blockchain, and then you're running this centralized service on top of it. So the DEX brings this all on chain. It makes it fully decentralized. And really the trick here is to have reserves of both loaded up in the contract. So what you do is you'll put in a whole bunch of tokens and a whole bunch of ETH at the ratio of whatever those tokens are worth. And then when people want to swap, they'll swap much smaller amounts between the two. And there's a really nice kind of like drawing in here. You'll see the constant product stuff. This thing right here. So I'm going to put in token A and get back token B, right? And that curve is the price curve. And with each trade, the sort of dot moves up and down that curve. And there's a really nice visual curve here. It actually like plots this for you. Let me see if I can find it. Where is that thing? Yeah, well, here it is, but it's not there. Oh, wait, is that a video? No, that would be cool. You'll see this curve, and you'll see it move up and down. And as you swap, if I put in a whole bunch of tokens, it's going to run down the line. And if I put in a whole bunch of ETH, it's going to go up the curve. And the price is wherever that dot is. And the amount of slippage is how far that kind of triangle comes out. You kind of have to dink around with it, but once you start dinking around with it in Scaffold ETH, it's like it becomes pretty obvious how this works. So your fifth app, the most important app, is this DEX. And what you do is you build a smart contract, and you have to write the code. You have to figure out how to set up the swap and how to make it figure out, based on the reserves, what the price is. And you have to really write the code and learn. And you'll have to get in here and do this. It takes a little bit of time. By the way, this DEX doesn't have slippage protection. Don't deploy this on mainnet or something. This is like a play DEX. You need to build more things into it to make it secure to put online, on chain. But it's good enough for you to learn. Here's how you calculate the price, right? There's this constant product where you figure out the token to ETH mixture. And then there's the token to ETH on the way in, and then the token to ETH on the way out, and they have to basically be equal. Okay, so there's the swap, right? You can go from token to ETH or ETH to token, but there's also a couple more functions on your DEX, and they're around putting these reserves in. You need to basically load it up with tokens and load it up with ETH, and when you do that, you get minted another token that represents your claim on the reserves that you're storing in that contract. And this is a really important concept, because what's going to happen here is that the reserves are going to earn you money. If you own ETH in that contract, you have that token that represents that money. As people swap, like 0.03 or something like that of that token gets left behind each time. So actually, if you look at a DEX with reserves in it, if someone swaps back and forth a bunch of times, the DEX sort of slowly gains value. It actually earns fees. So for you as the liquidity provider, you're earning fees, and this is what's called expansive in the term of hyperstructures. So I want to hit you up with this one. go look up a hyperstructure and spend some time reading this paper, because it's really inspiring and it helps kind of lean you toward building on-chain and thinking about how you put things on-chain and what kinds of things can be successful on-chain. It needs to be unstoppable, free, valuable, expansive. That's what I was talking about the LPs. Why would someone want to lock up all this money? Like, the more reserves you have, the better the swap is, but what's my incentive for doing so, right? You have to incentivize folks. It's permissionless, it's positive sum, it's credibly neutral. Check out a hyperstructure. So yes, you will create the smart contract. You'll be able to do ETH to tokens, tokens to ETH. You'll be able to put liquidity in. You'll kind of like learn all these intricate details. There's the curve right there. I knew it was here somewhere. And you'll end up shipping this to a test net. And you can just get in there and swap. You can get in there and put liquidity in, pull liquidity out. It's really like a little sandbox DEX that's, you know, the starter kit for building something like Uniswap. Okay, so those are your first 5 apps. You want to go speedrun these. We are always in the Telegram channels. There's a Telegram channel for each one. We're in there answering questions, so if you have questions, we're there. And we can, help you speedrun those if you have any questions. I think the last few challenges, let's just go look at those real quick, just so I can highlight those. You get to join the Build Guild once you complete the DEX, and that's basically, we have like onboarding batches, we do a small grants program, we basically prepare you to go ship something in the space. State channel application, looking at signatures, looking at L2s, looking at off-chain interactions. A multi-sig wallet would be having multiple signers that could all transact, or you need maybe like 2 out of 3 signers to be able to make a transaction happen. So this is really nice if you need like something more secure. A lot of good developers in the room. I've seen that if you're holding ETH, in large amounts, you want to have it in a multi-sig, right? You don't want to have it in an app or a hot wallet. You want to have it in a smart contract that has rules based on, you know, if you want to move money out of this smart contract, I'm going to need a signature from your phone, and I'm going to need a signature from your laptop, and I'm going to need like a signature from your hardware wallet, right? You have to get all of those together, or maybe 2 out of 3 of those together to make the transaction happen, and that's just much safer. It keeps the money safer locked up in the smart contract wallet in the multi-sig. And then the last one is a fun little just like SVG NFT. We started out with that first NFT, and you'll get in here and you'll learn about IPFS, and you'll realize that like the thing gets deployed to IPFS, and the only thing that goes on chain ends up being the link to the IPFS. So the thing that's on chain is more like a little JSON file that tells you where the stuff is. You're not actually putting the image on chain. So in this last challenge, we actually have you make an NFT where the actual SVG NFT is rendered from the smart contract, which is probably more nerdy than anything, but it's just cool to do, and it'll be a good lesson to learn. So that was like a bonus. Basically, your first 5 apps go up to the DEX, and the rest of these are kind of bonus challenges, but I would recommend you take time to go through them when you have some free time at home, or maybe just some free time around here. But you'll have to sit down and focus and actually write code. There's a lot of moments where you have to think for yourself. It'll say, hey, you need to make this thing happen, but there's not going to be code that you can copy paste. You'll have to write the code yourself. It gives you lots of help, but in the moment of figuring it out, like you have to figure it out yourself, and it's going to help you learn. Like that's the way to learn this. Okay, so that's Speedrun Ethereum. I'm Austin Griffith. We're the Build Guild. We are going to do the CTF after this, but I think Edda is going to come up and do some NFTs next. You going to do an NFT app? Awesome. Okay, and I don't want to close my laptop, but I'm good to go when you guys are good. Yes, thank you. Thank you. I should have done a question session, but we'll do a question session after this. We'll double the questions down.
Okay, is my microphone working? Okay, perfect.
Hey, Jan, how are you?
Okay, so hi guys. Now we're going to do some NFT apps, which Austin talked about using Scaffold ETH. And it's going to be a quick session, so I have 30 minutes and 45 seconds. So what we're going to be doing is we're going to be using Scaffold ETH, and it's similar to the first challenge of the Speedrun Ethereum, where you build an NFT application. And I'm just going to try to walk through each step on how we can do it, how we can deploy the contract, set up our new contracts, and kind of showcase how it works. So hopefully it will be a nice preparation for the Capture the Flag challenge this afternoon. And yes, let's directly get started because we don't have a lot of time. So all I did, and I want to show you what I did. Now all I did was I went to Scaffold ETH and I just downloaded so then we can save on time and make sure there's no error. You're welcome to follow along if you have your laptops open. And yeah, I took npx create ETH latest and I created my own Scaffold ETH application. I did nothing else. All the other steps we'll be going through together. OK, so where's my terminal? Cool. So I named it NFT Workshop. You can see over here I have the project. Let's kind of start our chain. I also didn't deploy the contracts, actually. So let's deploy what we have just to see what's going on in our app. And then I'm going to do a yarn start. And I kind of went fast, but I basically have 3 terminals over here, one running my local chain. I chose Foundry when I set up the Scaffold ETH application, but you're welcome to choose Hardhat if that's your preferred development environment. And then I deployed the first contract we have. This is like a basic smart contract. It's a Hello World smart contract, which we'll just look into very shortly. And then I did a yarn start to start my application. And let's open where I have too many browsers here. So I'm going to do like this. I'm going to open my local host here. I actually want like an incognito window. OK. OK, cool. So this is what you get. With all the Speedrun Ethereum challenges, you use the same toolkit. So once you kind of go through the first one, I think it makes you familiar. So the rest will come more easier. And what I have over here is this is like a sample front end to get started with. And then debug contracts tab, which makes it really easy, which Austin was talking about as well. You can kind of have, this is the initial contract which we just deployed. It's a greeting contract. You can see the details, like the address, the owner. All the functions available are displayed here. And what we're going to do is I want to add a new contract to our application, because you probably want to have more than one contract. So this is like a basic contract, but what Scaffold ETH makes you do is you can also have multiple contracts in your same app. So this way you can kind of work through them, like have them send each other messages or kind of link to each other. And that's what I'm going to showcase today. It's going to be an basic NFT contract, and we're also going to be building a small front end, as much as my front end skills allow. Now, I have it ready too, so no worries. I think it will work. OK, so what I did, and just to show you my app as well, this is what we just downloaded. I had it opened, and I have the Foundry folder, but if you choose Hardhat, when you do the wizard which starts your application, you will see it as Hardhat. And I will basically have over here this is the your contract, which we just saw. And is this good enough? Shall I zoom? It's good? OK. OK, perfect. So this is the your contract, which comes as the basic. You can see the details here. And I'm going to add a new contract, and I'm going to show you exactly how to do that. And one other thing. So I'm talking about what I'm doing, but the docs are pretty clear and show you all the step by step. So any questions you have about Scaffold ETH, you can basically come to the docs. What I basically just did before, just now as well, was to set it up using the create ETH latest, and then it tells you all the details. It tells you the details about the extensions as well. So you can definitely go default to the docs if you have any questions. They should definitely have your answer, and I'll be going to the docs a lot during this presentation. OK, cool. So let's get started. Now, as I said, I want to have a new NFT contract. And I'm going to go to Foundry because I chose Foundry. And I'll basically be using the Soulmate. I'm going to create an NFT with Soulmate. I'm at the Foundry docs. And they have where is this exactly? OK, they have the tutorials here. So I'm just going to copy and follow the tutorial to add the NFT contract. And then that'll basically be in my application too. And I come over here. So because we're using Foundry, I do need to install Soulmates. And I think we have the Open Zeppelin contracts, but let's make sure to install what it requires to create this NFT contract. OK, cool. So I'm back to my terminal. Let's just close this for a bit. I'm actually not sure. I need to go to the Foundry folder to install the dependencies. Oh, but yeah, it doesn't allow, so I'll just do like a no commit. So this should be fine. Oh, and I actually didn't mention that, and I probably should have mentioned it before I started too. But you can totally follow along what I'm doing in GitHub. I have over here a repo to explain what we're going to be doing now. So you can totally follow this along as well if you want to. I think it's fine. Like, we'll go through the steps, but I'll provide this link. But yeah, Devcon 24/CLS. So it has the steps which I'm going to be running through today. OK, so I'm installing the dependencies I need. OK, this was pretty fast. And I'm going to go back here. I'm going to do a yarn chain just so that we have this running. All I did was I went and installed the Foundry dependencies. I'm just kind of following this tutorial over here, and I want this contract. So this is like a basic NFT smart contract. It has like a name, a symbol, and then the mint2 and token URI functions here. And all I'm doing is I'm going to take it and put it in my Scaffold application. So to do that, now we have over here the your contract. I'm going to create like a new file here. Let's call this NFT contract. OK. And I just copy-pasted the code we directly took. Because we installed the dependencies, we should be fine. So now all I did was I added like a new NFT smart contract to our same application. But this will not automatically deploy. I also need to edit my deployment scripts, because when you do a yarn deploy, it only deploys the your contract by default, which is this one over here. So whenever you add a new contract, you need to update your deployment scripts. Or like, let's say, like you change the your contract constructor, then you need to add that to the deployment script details, so then it deploys all together. And where did we add that? OK, I think it's scripts. OK, so this is the deploy your contract. This is the initial script which deploys the your contract smart contract. I'm basically going to copy this and create the same one for my NFT smart contract. Command copy, Command V. I'll call this deploy. OK, I didn't do anything. I just copied it. I'm going to change the your details to NFT. NFT contract, deploy. It's also so cold in here. OK, I think this is fine. Now, this is actually not enough. You also need to add it to the deploy script. So I created like a new deployment script for my NFT contract, but I also needed to add it to this main deployer script. And you can actually also add it here, but this makes it just a bit easier, so then you can like add, change things without like messing the structure a lot. So this is like my new script, which we just created from zero, called NFT contract.deploy NFT contract.s.sol. And I'm going to add this to the main deployer, so then it also actually deploys. Because by default, when I run like yarn deploy, it only this is the folder which gets run. And thank you to devs who added the notes here. And I will copy this. And I will do a deploy NFT contract. OK, I think I need to also import this, but my Copilot should actually have told me this, but OK. So for some reason, Copilot was slow, but we got it. So I think this should basically deploy our new NFT contract, and let's kind of see if that works. And if not, we'll figure it out. But I think it should work. So by the way, like when you deploy, I generally do a yarn deploy reset to make sure that nothing gets saved. Oh, OK, I remember. So I think there's an issue with the Foundry, like the Solidity version from our NFT contract. This is like quite old, so I think if I do this 20, this should work. This is an error of Visual Studio. I don't know why this keeps giving me like import errors, but I think this should work. Like it was 8.10, but that's pretty outdated, so I think this should work now. Okay, so this is fine. I think this is like or I can just call the other one NFT. I'll actually call this one. So this was called NFT, but I think it should be called NFT contract. I think this is better since we named our file NFT contract. It's always hard to do online demos, but I didn't edit the constructor. So our constructor is probably empty, so that's why it's giving an error. Okay, oh no, it's not empty. I need to give it a name and a symbol. So because I just copy-pasted, I should have actually checked where what the constructor takes. And in my deployment script, I didn't add any of the constructors. So over here, all I need to do is I need to add my constructors. So I'll just call my token, whatever name, and then I'll give it a symbol, right? Is it name symbol or symbol name? Name and symbol. And the name will be like Edda's. I don't know if this creates like legal problems, but Edda, because my name is Edda. Okay, cool. Hopefully this should work now, right? Let's make sure that we don't have any errors. This is that line. This is here. We give the arguments here. I don't think there's any more issues, to be honest. Do I have it wrong here? Okay, 1 second. I'm gonna like just cheat over here. I think we should add it here though. Okay, cool. So I added my constructor arguments at the wrong place. But basically, the issue was I need to give my, when I run the contract, because my constructor takes 2 arguments, the name and the symbol, I wasn't doing that correctly. So now we basically deployed like a new contract, and let's look at it on our application, which I think is the cool part. So I didn't edit any front end. All we were doing was we added a new smart contract. It was a bit stressful, but we managed. So we have like a new deployment script, and we have a new smart contract. And then over here, it directly comes on our front end. So as you can see, now there's like 2 contracts, the your contract and the NFT contract. And I kind of can play around with this without making any other changes. So this, yeah, I think this is pretty cool. Like when I was like first starting and I wanted to add like multiple contracts, I found it quite hard. Like you need to like manage the dependencies, like all the new libraries and stuff like that. But by this, like you can just add like a new smart contract. You don't need to like, you can of course like write the tests and everything, but it automatically appears on your front end before doing anything else. And let's see how this works. So I directly click this button, but what this does is it gives me some funds from the faucets. If I hadn't clicked it, it would have given me like a gas error. It would say like you have no money to pay for gas. So I directly clicked it, but let me show you what happens if you don't click it too. Oh, this one. I'll go to like my browser over here. It's burner wallet, so it generates on new browsers. So this one has like 0 ETH right now. So I can go to the debug contracts tab. I can go to NFTs. Like let's say I want to like mint 2, and I give this my address. Let's give this address. And then the value, like I don't want to give any money right now. I send, but it gives me gas error. So that's why I had automatically clicked that burn, like the faucets. Yeah, grab funds from the faucets button. Hopefully now it grabs funds. It's all from my Anvil local chain, so we're just on localhost right now. Cool. So as you can see, I minted an NFT to this address, and I can send it to like this address, the green, purple, the orange one as well. And this is kind of how it works. And Let's do this again on this person. I'm not going to send any money to it, but you can. Perfect. So it's pretty easy to like add a new contract, and when you go through the challenges, you'll either like modify the existing smart contracts, or you'll be adding like new smart contracts. And this is kind of like how you can work with Foundry and add like new dependencies and then create your new contract. And what I want to do is, so we have this like this web page, but let's say you built like an NFT app. Like you don't want to show this web page to your users. You want to have like something better. That's why we kind of have the initial page to get you started as well. So I have like 15 minutes and 6 seconds left. So I'll try and like build a small front end where you can automatically mint NFTs from that page instead of sending this page to your users and being like, hey, like go to debug contracts tab and then mint from there. Okay, time goes by much faster when you're in a rush, I guess. Cool. So yeah, the error is the dependency error. I think like Visual Studio Code or like my extension gives it an error, but it's actually like we have the contracts in the lib folder. I don't know why I had the problem earlier. So what I'm going to do is now I'm done with the Foundry folder. We have our smart contracts. Everything's working. If I want to add more, I will add more. Actually, we will be adding more because it doesn't set a maximum supply. The default just like you don't set a maximum supply in the NFT contract. So I kind of want to do that if we have time. So what I'm going to do is I go to the Next.js, the app, and then I'm going to create a new folder here, and I'll call it NFT. And then I'm just going to copy this page.tsx, but this is. And then I'm just going to paste it here. Or I'll just like remove everything from here. What I'm doing is I want to create a new page, which we can go to like localhost/NFT. And this is kind of the way Next.js arranged it. And I just want to create that. Let's just call this NFT. I think this should be fine. Okay, so I'll be editing all this, but let's make sure that it works. Cool. So what we did was right now you only have the home and debugs contract. I create like a new folder in my Next.js app, and then it goes to like by default the NFT extension because that was the name of my folder. And I have a page.jsx there which displays this. But I don't want to display this. So let's just delete this and let's just show hello. And let's actually like remove the secondary background because that's not nice. Cool. So okay, so we kind of have an initial app. We have like an initial web page. Now what I want to do is I want to pull the NFT contract information here. So then it gives you a button to just like you see the NFT, you click it, and you mint it. And for that, I'm going to go to Daisy UI. Scaffold uses Daisy UI, so you don't need to like work a lot on your front ends. Like I don't build many front ends, so this makes it very easier to just like go and get the components and have them be displayed on your app. And I'm going to go over here to the components, and you can directly use any one of this. I'm going to use the card component. The card is somewhere here. Oops. I just take the card. So this is what it gives me. Let me just copy paste this. You can use any components. Like it has different like headers and bubbles, countdowns, stuff like that. It makes it really easier. Like I highly suggest it. If you have any other framework you use, that's obviously fine. But I'm just going to go and paste this here. So this is the shoes card. I'm going to go to the NFT tab. Cool. So all I did was let's open it here actually. All I did was I went ahead and I got this shoes card component, and what I wanted to do is I don't want like a Nike advertisement, but instead I want to have my NFT details there, and then it will show like NFT, and then this button will be mint now. And then let's actually like center that too. Okay, so the image we should change, and then NFT mint here. This is not a funny joke. And then you do a mint here. I think I can do items center. Flex. Okay, I didn't manage this, but. Okay, for now this is fine. Let's just make it working, and then we can do all the other details. I'll also remove this night picture because it's kind of. Okay, cool. So NFT mint here, and then the mint button should be our NFTs. And what we want is we actually should see the NFT details, right? Like what's the token name, how many NFTs are left, etc. So I do really want to see that information. And to do that, I need to read from my smart contract. So I'm going to go over back here to the Scaffold Heat docs to show kind of how you do that. But Scaffold Heat has built-in hooks, so you can directly use the hooks, which kind of allow you to interact with your smart contracts. By the way, I mentioned it directly uses WAGMI and WAGMI hooks, so it's kind of easier to use the Scaffold Heat hooks when you kind of work with it. And Daisy UI details you can kind of find over here as well. But I'm going to go over here. This gives you a shortcut, like recipes gives you a shortcut too, but I'm just going to show the read contracts hook. So I'm just going to copy this. What this does is it allows, it directly provides a hook for me to read my smart contract data. And then I'm going to add it here, and then I'm going to just change it. It's going to tell me I need to import it. Let's just do that. And then it's going to be my NFT contract. And then I don't remember what we had on our NFT contract, but over here, let's get the current token ID. Let's just show that for now. There is no arguments. I think I can just delete this. And then I do the token. I also want to get my address. Let's show the connected address. And I everything is on the docs over here, so it makes it very easier to get your connected address. As you can see, we directly use WAGMI, use account from WAGMI. But I also want to show the address when we go to our NFT page. And I'm going to do this address. This is going to import from WAGMI. And then let's add it here. Let's add a H1. I probably need to wrap the token ID to an integer or something like that, but let's see. Oh, okay, I need to do, it's the client side. Because I'm using client components on my Next.js app, I do need that. Okay, so cool. It shows me my connected address, but instead of showing it like that, I want to use directly the Scaffold address component. It just makes it look better. As you saw, doesn't look really nice. You probably don't want to have this. So I think there's directly an address or account. Is this okay, cool. So I'm going to delete this. It will give me a blocky and an avatar, automatic ENS resolution. This is just perfect. So now, okay, so there's no ENS resolution because we're on localhost, but as you can see, it's kind of gives me just a better view over here with my connected address. And then the token ID, I think I need to wrap this in something, an integer. Cool, because it resolves big numbers, so the big number format doesn't match, so you need to convert it to a number format. But OK, cool. So basically, we directly use the scaffolded address component. We now have this here. And we want to have like the mint button working, because right now it does nothing. But what we were able to do is we added a new smart contract. Now we have like a new page which displays the details of that smart contract. Its token ID here, NFT mint here, and then the mint button. What it should do, it should mint an NFT, and then once it does, like you'll automatically see the ID increase. And I have 5 minutes left, but it should be OK. So I'm going over here to the scaffolded docs again. I have too many tabs open. And then interacting with your smart contract. I came back here because we were using the read hook before. Now we need a write hook, because basically we're going to make change, like we're going to like mint a new token. So we need to like interact with our smart contract. So a read is not enough at that point. And it's quite simple to like use the use scaffold write contract hook. I'm going to directly copy, like this is, you need to define this up here. Quite similar the way we did like the use scaffold read contract. It's just going to be a use scaffold write contract. We need to import this. Let's do that. And then it's going to be like NFT contract, because this is the new contract which I'm working with. OK, so I basically pulled in like a write hook. And now I want my mint button. And all I do is it gives you like an example usage over here. So I'm going to copy this, and then we'll just edit it. The mint button, I think we can just, OK, I'm going to delete this mint button. The function name is it mint2? The function is called mint2, and it takes an address. So I'm not going to forget to add the address. The function name is mint2. The args are going to be the address, and we don't need to pass any value. But if you say, you know, like mint for 1 ETH, you can add that. Probably want to add that to your front end too. But all I'm going to do is I'm going to like for now like actually just pass in the connected address. But I can just do like this. This should be fine. Oh, I don't need these, maybe. OK, I think this should work. So basically what we did is we pulled the write contract hook. We added like a new button. And the button is called, well, not set greeting, but let's call this mint here. And then I don't want it at the end. And then yeah, this should work. Let's see. So when you mint here, basically, it should increment the token ID, because we minted a new token. And then you should be able to see that. Transaction completed. So the token ID is now incremented because we were able to mint an NFT. Now, of course, you probably want to show like a receipt over here of how many NFTs left. But because I have only 2 minutes left, what I'm going to do is I'm going to quickly modify our smart contract to have like a total supply and display that on the web page. I think we should have enough time for that. uint, all I'm doing is like a new uint. Like let's call this max supply. Let's say 10. 10 is enough. And then this should like have a new require. OK. So I edited my smart contract because by default it doesn't have a max cap right now. And I want only 10 NFTs to be minted. I also then want to display this on my front end too. So I'm going to do that. But let's first redeploy our smart contract to make sure that, or I think it's OK. We didn't do much changes. But now we have a max supply. But I'll just redeploy because then it will give me an error when I try to add max supply is not there. OK, so I quickly edited my smart contract. I now have a max supply, and I want to display that detail on my front end. So then you can kind of have like a counter, which is a bit more fun. I'm going to use the read hook because it's just like a value which we read, so you don't need the right one. And this is called max supply. And then I'm going to call this max supply. And then what do we do over here? The token ID. Instead of, we don't need the token ID. Let's say supply, like left, NFTs left. Well, NFTs left is max supply minus the ones we've minted. So I'm going to do that minus Let me first display max supply, and then we'll do the subtraction count. Do we do the max supply wrong? But this is the max supply. Oh, thank you. Thank you. I should have this, right? The max supply. Yeah, okay. Perfect. 30 seconds left, but this should work. Okay, so now we have 10, and then we mint. Well, the max supply is still 10, but what we can do is we can quickly add like a minus. Ooh. I'm not sure I can do the operation here. Do I need to do like it here? Okay, my eyes are not working now. Oh, okay, got it. I'm finished.
Okay? Okay.
It's working.
Woo, Hannah. Yeah.
We can show that too. I actually have 10 more seconds left.
You did it. It was great. You want to hang out up here?
Oh, yeah, if you have any questions.
Next is a Q&A, and you can shoot this QR code and send questions to the board. But also, like, you can just yeet them out, and we'll hear you and answer the questions too. Also, there's like 10 build guilders all over here with these things on. You can just come talk to us, and we can answer a lot of questions. For instance, if you're bringing up scaffold ETH and you have some like debugging error or something, just bring it over here to these guys, and they can help out. But yes, if you have any open questions, there is a QR code. Also, you'll notice that if you go through Speedrun Ethereum, within each one of the challenges, there's a Telegram group. And in that Telegram group, we're sitting there listening to you. So if you have any questions, we're there and we can help. So questions, maybe hands, maybe you shoot the QR, very open here. I think we'll do like 10 minutes of questions, and then we will start the CTF.
We can have questions directly too,
Hearts,
right?
hearts, hearts. Any resources for Python maximalists? So that's going to be different. You're probably going to want to use Viper, which is a different language. Solidity is more like TypeScripty, right? So if you are a Python maximalist, I would go look at Viper, and I'd specifically look at Patrick Collins' work. He does a lot of Viper work, and he's a really, really good teacher and a really good DevRel. So look up Patrick Collins and Viper if you are a Python maximalist.
Hi, question.
Yes, sir. Where are you?
Right here.
Oh, there we go.
So you use Daisy UI on the front end. How hard would it be to use something else like ShadCN instead? Or would we lose some? What would we lose and what would we gain?
Nothing. You could just bring in that other. It's sort of like we provide
Yeah.
the scaffolding, and it's kind of a pretty opinionated scaffolding, but you can carve out our stuff and put in your stuff. You can try different things. Can anybody over on the Scaffold ETH team, do you guys know anything about putting ShadCDN into Scaffold ETH? Has that been something we've talked about? Oh, he's busy. Do you know, Shiv, if we're thinking about putting ShadCDN into Scaffold ETH, or how hard it would be to use ShadCDN?
Like you could bring it, yeah, like you could actually it's compatible, so like you could install ShadCN and start using it. So yeah.
So it seems like a thing. You might have to carve out some Daisy and put in some Shad, but it seems
Yeah,
like
I mean both works directly.
Yeah, I think the one.
what you should do
I
is make
tried
an
it.
extension
Yeah.
that if you make a Scaffold ETH extension that uses ShadCDN, and then we can cross-promote it between the two of us. That could
Right,
be
that,
cool.
that was the next question. Because
Looks like some nerds are arriving for the CTF. That is a good thing to see. I love to see some nerds coming in with some backpacks. Think about doing some hacking. Hell yeah.
Yeah.
So,
yeah,
great
there-
question.
Yeah, there were already components like the account display. I would lose those. I'd have to rewrite those myself with
I think
ShadCN.
so.
Okay.
No, those aren't. Yeah, you might have to rewrite those for ShadCDN. Yeah, darn it. Yeah.
Cool.
But do that and make it open source and let us cross-promote it with you. So people who like ShadCDN could go use those.
So what would you do? Would you fork it, create a branch, and then contribute it?
There's a really good video by Hunter, I think he's here somewhere, on how to build extensions. I think the first thing I would do is I would just fork Scaffold ETH and make it work, and then I'd take the work that I put into that and put it into a Scaffold ETH extension. And there's a video that kind of takes you through how to make an extension, and then it stays state of the art. So you could use Scaffold ETH plus whatever extension you've added, and we can kind of cross-promote it and show it off to people.
Thank you.
Cool, thank you. We got a hand here. Oh, you got him. Go ahead. Yep.
So we have used Hardhat and the Foundry, right? So is there any advantage or limitations between these two?
Yes, so the two are different. They're great for, you said Hardhat and Foundry, right? Just to make sure. Okay, so Hardhat is a little bit older. It's a little bit slower. It's more TypeScript tests, but they're starting to carve things out and act more like Foundry. Foundry is faster, it's written in Rust, and I think the key thing there is you're using Solidity to write your tests, whereas with Foundry you were using TypeScript to write your tests. And so as a Solidity developer, writing those tests in native Solidity just makes a lot more sense and it's a lot smoother. However, if you're an app developer, you want that TypeScript because you want to copy and paste it into your front end. So having Hardhat is also kind of good for the front end folks too. So the answer is Foundry is the state-of-the-art best tool. Hardhat is a really good tool, and before Hardhat we had Truffle and it was awful. Sorry to the Truffle guys, it was fine and did what it needed to do. Also, Hardhat is catching up. They're starting to use Revum, which is the technology, the chain underneath Foundry. They're starting to rewrite some stuff in Rust. I would say that their deployment process is a little smoother, but I kind of just randomly pick them depending on, like if I'm going to do a lot of like yarn forks, I'll usually use Foundry, but kind of sometimes I default back to Hardhat just because I'm used to it. But the difference is kind of the testing in Solidity versus testing in TypeScript, I think is the key thing, and Foundry's a little faster still.
Got it. Thank you.
Okay, there's one over here somewhere. There we go, yeah.
What's up with the build guild Ethereum node? Is it like a normal node? Or
yeah, so you can go to client.buildguild.com or client.biddlegiddle, and what it is it's a process that runs that spins up Reth and Lighthouse in the same node. And then there's even like this opt-in that you can do where you can opt into our distributed RPC network. And you start earning some credits that have no value. It's just numbers in a database. But you earn credits for serving RPC requests to our apps. So we build a bunch of apps on chain, and we use the Build Guild RPC, and it's served by this sort of distributed set of nodes. And we pay them back in credits, but that's not a real thing yet, and it doesn't have any financial value.
Not yet.
Right. No, not ever, not ever. But it's just an easy way. It's like a one-line command. You can run a one-line command, and it brings up a whole cool Ethereum node. But you'll need like a couple terabytes of space, right? 1.2 or 2? Just straight up 2? Okay. And Spencer's the man to talk to about that. He wrote that software. Good question. Did that answer your question? I think it did, right?
How can I run the nodes?
You just go to client.buildguild.com and copy paste that command into your terminal, and it'll run.
Okay.
Wait, is that a Windows machine though? What is that? Linux?
No, macOS.
It's a Mac?
Yeah.
Oh yeah, there's like a one-line command, copy the one-line command into your terminal, and you'll have a node running. The thing is, it'll just take up a lot of space.
Okay, I have one more question.
Okay.
How do you pronounce the name of the...
Build Guild? I just say Build Guild, but definitely it is Biddle-Giddle, right? It's misspelled on purpose, and it's like the HODL meme, right? The HODL meme and then the Biddle meme. So yes, it is Biddle. Oh, look at these nerds coming in for the CTF. Yes. We're going to set this off. This is going to be great. We might need more chairs. Yeah, I just say Build Guild, but it is spelled Biddle-Giddle, but I don't know. Do we have more questions here? Do you guys have scaffolds for other frameworks like Angular? No, it is just React. I think someone made a Svelte. I think Byte at a time made scaffold Svelte. If you go to Build Guild, like biddlegiddle.com, you can go to the app and you can look through all our builds. And within those builds, you could search for Svelte, but I don't think there's one for Angular. Nerds, yes. Why is there not enough? What was that top one? Soccer? Oh, sockets. Where are there no, oh no, do we, like plugins back there, is that what you're talking about? Yeah, we didn't think we were gonna have this many people, I think. We'll have to figure something out. Maybe some other people will clear out before the CTF starts. Please don't, please stay, please hack. But if we need more outlets, we'll have to figure it out. We'll maybe call them in or something. But yeah, there are not a lot of power outlets in here. That might be tough. I'm not sure what we can do about that, but we'll talk to them. Vue.js, no, it's all React. How hardcore of a dev do you have to be to participate in the CTF? Okay, that's great. We will answer that question in just a second, but the TLDR is even the worst dev can figure out the first couple levels, but even the best dev in here is going to have a hard time with the last couple levels. So you're going to have a very easy entry into the CTF, but it's going to get very hard toward the end, I think. Building a multi-user communication dApp scaffold ETH is easy? Maybe. I mean, that sounds complicated, but maybe.
35 seconds.
Okay, we got 30 seconds, and then we're going to switch to the CTF, which means I need to grab my laptop.
Can
you do the CTF without a laptop? I think you're going to need a laptop.
Yeah, that might be a bit hard.
Is this my machine? Okay. Okay. Got 10 seconds left. You want to take that?
Yeah, I got it.
Any last questions? Come on in, get ready for the CTF. There's also a POAP. Collect the POAP. If you are here, collect it. Okay.
Oh my God.
If we could bring up my screen here. Ooh, that's not me. And I think we're actually shutting off the live stream, right? I don't think we're live anymore, or are we still live? We're still live? Oh, hold it? Hold the mic or hold? Oh, this is being weird? Okay. Oh, hey, here's my Build Guild client right here. See it running? So it's syncing still. But you can see disk activity, network activity, CPU load. You can see the lighthouse.